Picture a dimly lit library in Istanbul, circa 1929. Dust motes dance in filtered sunlight as scholars carefully unfurl a parchment that will shake the foundations of history. The map before them bears the signature of Piri Reis, an Ottoman admiral from 1513. But what captures their breath is not the signature. It is the impossible detail of coastlines that shouldn't exist. The parchment crackles softly as they trace their fingers along meticulously drawn shores. Here, etched in fading ink, lies the coast of Antarctica, a continent that European explorers wouldn't officially cite for another 3 centuries. Yet this map shows not just the continent's outline, but details of its ice-free coastline, mountain ranges, and river systems that modern satellites would only confirm in the 1950s. Is the world of impossible cartography, a realm where ancient maps whisper secrets of lands that shouldn't have been known, couldn't have been explored, yet exist in stunning accuracy on parchments older than the voyages of Columbus. These are the secret maps documents that suggest our understanding of human exploration, ancient knowledge, and perhaps even the very shape of our world may be fundamentally incomplete. The mainstream narrative tells us that European exploration truly began in the 15th century, that before Magellan, before Columbus, before the Great Age of Sail, humanity's knowledge of distant continents remained fragmentary, mythical, uncertain. We are told that Antarctica was discovered in 1820, that the Americas were unknown to the Old World until 1492, that accurate mapping required modern instruments and methodical exploration. But scattered across museum vaults and private collections lie maps that challenge this comfortable timeline. Maps that show lands with impossible precision. Maps that depict coastlines as they existed thousands of years before their supposed discovery. Maps that hint at a lost age of navigation, when humanity or something else possessed knowledge that has since vanished into the mists of forgotten history. Consider the implications. If these maps are authentic, if they truly represent ancient knowledge, then entire chapters of human history remain unwritten. Somewhere in our past lies a civilization capable of global navigation, precise surveying, and cartographic knowledge that rivals our own modern capabilities. A civilization that mapped Antarctica when it was free of ice. A civilization that knew the true shape of continents before they were discovered. The conventional explanation suggests these maps are compilations, copies of copies, drawn from fragments of earlier Roman or Greek sources, embellished with medieval imagination and Renaissance speculation. Cartographic accidents that occasionally stumbled upon accuracy through coincidence rather than knowledge. Scholarly consensus maintains that no ancient civilization possessed the maritime technology or astronomical knowledge necessary for such precise global mapping. Yet as we examine these documents more closely, a different possibility emerges. What if these maps preserve memories of an earlier age? What if they are fragments of a lost golden age of exploration, when humanity or visitors to humanity charted the globe with methods we no longer understand? What if the age of exploration was not humanity's first venture into unknown waters, but rather our fumbling attempt to rediscover paths once walked with confidence? The ancient world holds curious anomalies. The Antikythera mechanism, discovered in a Roman-era shipwreck, revealed computational abilities that historians believed impossible for its time. The precision of Stonehenge's astronomical alignments suggests mathematical knowledge that predates written history. The Great Pyramids demonstrate engineering capabilities that challenge modern understanding. Perhaps precise cartography represents another lost art, another fragment of vanished knowledge waiting to be rediscovered in forgotten archives. As we embark on this journey through impossible maps and hidden continents, we find ourselves standing at the edge of a vast ocean of mystery. Each map we encounter will challenge our assumptions about the past, about human capabilities, about the very nature of knowledge itself. These are not merely historical curiosities. They are windows into a world where the impossible becomes routine, where ancient wisdom preserved truths that modern science is only beginning to rediscover. The maps call to us from across centuries, whispering of lands beyond known horizons, of continents that exist in dimensions of possibility we have yet to explore. They speak of a world larger, stranger, and more mysterious than our textbooks suggest. They hint that somewhere, perhaps hidden beyond the edges of our current understanding, lies another continent, not necessarily geographical, but conceptual, waiting for humanity to remember what it once knew. Long before satellites traced every coastline and GPS systems calculated positions to the meter, the world existed in the minds and memories of extraordinary individuals. These were the mapmakers, part explorer, part artist, part keeper of humanity's greatest secrets. In the medieval scriptoriums of Europe and the astronomical houses of the Islamic world, cartographers bent over parchment and vellum, translating whispers of distant lands into lines and symbols that would guide voyagers for centuries to come. The art of mapmaking emerged from necessity, but it evolved into something far more profound. In the 12th and 13th centuries, as trade routes expanded and pilgrimage roads crisscrossed Europe, maps became more than mere navigational aids. They transformed into repositories of cultural memory, blending geographical knowledge with religious symbolism, historical record with mythological tradition. The famous Mappa Mundi of Hereford Cathedral, created around 1300, presents not just a map of the known world, but a cosmological diagram encompassing heaven, earth, and the realms between. These early cartographers operated in a world where information traveled slowly and often arrived, distorted by time and retelling. A sailor's account of strange coastlines might pass through a dozen hands before reaching a mapmaker's workshop. Details would shift, distances would blur, and imagination would fill the gaps left by incomplete knowledge. Yet within this seemingly imprecise system, patterns of remarkable accuracy emerged, accuracies that modern historians struggle to explain. The Islamic Golden Age produced cartographers of extraordinary sophistication. Al-Idrisi, working in 12th century Sicily, created world maps of stunning detail and accuracy. His Tabula Rogeriana remained the most accurate world map for 3 centuries, incorporating knowledge from Arabic, Greek, and Latin sources. More mysterious still were the works of scholars like al-Masudi, whose 10th century writings describe lands and peoples that wouldn't appear in European accounts for centuries. As the Renaissance dawned, mapmaking underwent a profound transformation. The rediscovery of Ptolemy's Geographia in the early 15th century provided European scholars with a mathematical framework for understanding the world's dimensions. But this classical revival coincided with something unexpected: the emergence of maps that seemed to surpass even Ptolemy's sophisticated understanding. The workshops of Venice, Genoa, and later Antwerp became centers of cartographic innovation. Here, master mapmakers compiled information from returning voyagers, Portuguese navigators, Spanish conquistadors, and Dutch traders. But they also drew upon older sources: Byzantine manuscripts, Arabic treatises, and documents whose origins had been forgotten even then. In these workshops, knowledge from multiple civilizations converged, creating maps that synthesized information spanning millennia. Abraham Ortelius, creator of the first modern world atlas in 1570, openly acknowledged that his maps drew upon ancient sources, whose accuracy sometimes exceeded that of contemporary exploration. Gerard Mercator, whose projection system still bears his name, incorporated geographical knowledge that his contemporaries couldn't verify until centuries later. These weren't merely skilled technicians copying the work of recent explorers. They were scholars attempting to reconcile ancient wisdom with modern discovery. The mapmakers operated within a tradition that valued preservation above innovation. Medieval and Renaissance cartographers often saw themselves not as creators of new knowledge, but as guardians of ancient wisdom. They copied, compiled, and preserved, believing that their role was to prevent the loss of geographical knowledge that had been accumulating for thousands of years. This preservation instinct may have saved fragments of information that would otherwise have vanished entirely. Strange patterns emerge when we examine the transmission of cartographic knowledge. Certain geographical details appear on maps decades or centuries before they are officially discovered. Coastlines are depicted with accuracy that exceeds the navigational capabilities of their supposed era. Remote islands appear in correct positions despite the absence of any recorded voyage to their locations. These anomalies suggest that mapmakers had access to information sources that have since been lost or forgotten. The guild system that governed medieval crafts created an environment where secret knowledge could be preserved across generations. Master cartographers trained apprentices not just in the technical skills of drawing and calculation, but in the deeper mysteries of their craft. Some workshops maintained private libraries of maps and manuscripts that were never made public. When these workshops closed or their masters died, their accumulated knowledge often vanished with them. By the 17th century, as scientific method began to influence cartography, a curious divergence emerged. While newer maps gained accuracy through systematic observation and measurement, they sometimes lost details that appeared on earlier charts. Remote coastlines that had been correctly depicted in medieval maps disappeared from later versions, only to be rediscovered by modern explorers who found the ancient depictions startlingly accurate. The legacy of these mapmakers extends far beyond their technical contributions to navigation. They preserved fragments of human knowledge that span the entire history of exploration. In their carefully drawn coastlines and precisely calculated coordinates, they maintained a dialogue between past and present, between ancient wisdom and contemporary discovery. Their maps became bridges across time, carrying whispers of forgotten voyages and lost civilizations into an age that had the tools to verify their impossible accuracy. In the personal study of Kemal Ataturk, as he sorted through the treasures of Topkapi Palace in 1929, a German theologian named Gustav Adolf Deissmann made a discovery that would ignite decades of scholarly debate. Among the Sultan's collection of ancient manuscripts, Deissmann found a partial map drawn on gazelle skin, bearing the date 1513 and the signature of Piri Reis, an admiral in the Ottoman Navy. At first glance, the map appeared to be another Renaissance curiosity, a regional chart showing the Atlantic coastlines of Europe, Africa, and the newly discovered Americas. But as scholars examined it more closely, they realized they were looking at something far more extraordinary. The map didn't just show the coast of South America. It showed it with startling accuracy, including details that wouldn't be officially mapped for centuries to come. Piri Reis had been a remarkable figure in his own time. Born around 1465, he combined the roles of admiral, cartographer, and scholar. He participated in numerous naval campaigns throughout the Mediterranean and had access to the finest geographical knowledge of the Ottoman Empire. His great work, the Kitab-i-Bahri, Book of Navigation, remained a standard reference for Mediterranean sailors well into the 18th century. But the 1513 map represented something different, a document that seemed to transcend the geographical knowledge of its era. The map's depiction of South America extends far beyond what any European explorer could have charted by. 1513. Columbus had made his final voyage in 1504. Amerigo Vespucci's expeditions had traced portions of the eastern coastline, but vast sections remained unexplored. Yet Piri Reis's map shows not only the general outline of the continent, but specific geographical features, river mouths, coastal mountains, offshore islands depicted with an accuracy that would not be achieved by European cartographers until the late 16th century. More puzzling still is the map's southern extension. Below the known coastline of South America, the chart shows additional landmass extending eastward. For centuries, scholars dismissed this as cartographic fantasy. Medieval mapmakers often filled unknown regions with imaginary continents. But in the 1960s, researchers made a startling connection. When compared with modern satellite imagery of Antarctica's subglacial topography, the mysterious southern landmass on Piri Reis's map bears an uncanny resemblance to the northern coastline of Antarctica, as it would appear without ice. The implications are staggering. Antarctica has been locked in ice for millions of years, according to conventional geological understanding. No civilization in recorded history should have been able to map its ice-free coastline. Yet here, on a Turkish admiral's chart from 1513, appears what seems to be precisely such knowledge. Either the map represents the most extraordinary coincidence in cartographic history, or it preserves information from a source that defies our understanding of the past. Piri Reis himself offers a tantalizing clue about his sources. In notes written on the map itself, he states that he compiled it from approximately 20 earlier charts, including maps drawn in the time of Alexander the Great, Arabic charts from the medieval period, and 4 Portuguese maps showing the recent discoveries in the New World. He specifically mentions having access to a map that had been in the possession of Christopher Columbus himself, a chart that Columbus supposedly obtained from someone who had been to these lands. The admiral's claim to have used ancient sources raises profound questions. What maps from the time of Alexander the Great could have shown the coastlines of America and Antarctica? Alexander's empire, vast as it was, never extended beyond the borders of the known ancient world. Yet if Piri Reis's sources were authentic, they suggest that geographical knowledge of far greater scope existed in antiquity than historians have ever imagined. Modern analysis of the map has revealed additional mysteries. The projection used by Piri Reis appears to be a modified azimuthal projection centered on Cairo, a sophisticated mathematical technique that requires precise knowledge of the Earth's spherical geometry. Such projections were not supposed to exist in 1513 and wouldn't be formally developed by European mathematicians until much later. Yet the map demonstrates not only familiarity with spherical projection, but applies it with remarkable accuracy. The coastline details continue to baffle researchers. The map shows the Falkland Islands in approximately correct positions, despite their official discovery not occurring until 1592. It depicts river systems in South America that match modern geographical surveys. Most remarkably, it shows what appears to be a land bridge connecting South America to Antarctica, a connection that geological evidence suggests existed millions of years ago, long before human civilization supposedly developed the ability to conduct global surveys. Skeptics have proposed various explanations for the map's accuracy. Some suggest that Piri Reis extrapolated from limited Portuguese sources, using educated guesswork to fill in unknown regions. Others propose that the southern landmass represents not Antarctica, but a misinterpreted depiction of the South American coast, distorted by the map's unusual projection. Still others argue that later copies of the map may have been enhanced with knowledge gained after 1513. Yet for every conventional explanation, new puzzles emerge. The map's accuracy extends to minute details that would be difficult to achieve through guesswork. The mathematical sophistication of its projection exceeds what should have been possible in 1513. Most significantly, the map appears to show geographical features that wouldn't be fully understood until the advent of modern geological and satellite surveys. The Piri Reis map stands as perhaps the most famous example of impossible cartography, but it is far from unique. Its existence suggests that geographical knowledge of extraordinary scope and accuracy circulated in the ancient and medieval worlds. Whether this knowledge originated from forgotten civilizations, advanced ancient technologies, or sources entirely outside conventional understanding the map of Piri Reis continues to challenge our assumptions about the limits of historical human knowledge and the true scope of ancient exploration. Imagine Antarctica as it appears on certain ancient maps, not the frozen wasteland of modern reality, but a continent of rivers and valleys, mountains and forests. Green lands where now only ice exists. Coastlines detailed with the precision of a modern survey, showing bays and inlets, river mouths and harbors that today lie buried beneath miles of glacial ice. This is the Antarctica that emerges from maps drawn centuries before the continent's official discovery. Maps that depict it as if observed by explorers who walked its ice-free shores. The concept defies everything we understand about both geological time and human history. Conventional science tells us that Antarctica has been frozen for approximately 34 million years. The last time significant portions of the continent were ice-free, no mammals walked the Earth, let alone humans capable of creating accurate maps. Yet scattered across the archives of early cartography are documents that seem to show precisely such an ice-free Antarctica, mapped with detail that modern researchers are only beginning to appreciate. The phenomenon extends far beyond the famous Piri Reis map. In 1531, Orontius Phineas created a world map that shows Antarctica, which he called Terra Australis, as a distinct continent in the Southern Ocean. His depiction includes not only the continent's general shape, but internal geographical features, mountain ranges, river systems, and coastal details that align remarkably well with modern knowledge of Antarctica's subglacial topography. The map even suggests the presence of major ice-free areas, particularly around what we now know as Queen Maud Land. Philippe Bosch's map of 1754 presents perhaps the most extraordinary example. Drawn nearly 70 years before Antarctica's official discovery, Bosch's chart shows the continent divided by a waterway, essentially, depicting Antarctica as two large islands connected by ice. This detail seemed purely fantastical until the 1950s, when seismic surveys revealed that beneath Antarctica's ice sheet lies exactly such a division. The Transantarctic Mountains create a geological boundary that effectively separates East and West Antarctica, with the western portion's bedrock lying largely below sea level. Without ice, Antarctica would indeed appear much as Bosch depicted it, two large landmasses separated by water. The accuracy of these details raises profound questions about the sources available to early cartographers. How could Orontius Phineas, working in 16th century France, have known about mountain ranges that wouldn't be detected until radar penetrated Antarctic ice 4 centuries later? How could Philippe Bosch have understood the geological structure of a continent that official expeditions wouldn't even cite for another 66 years? The traditional explanation suggests that these maps represent educated speculation rather than actual knowledge. Medieval and Renaissance cartographers often filled unknown regions with imaginary lands, drawing from classical sources like Ptolemy, who had theorized about southern continents necessary to balance the Earth's northern landmasses. The similarity between these speculative continents and actual Antarctica could represent remarkable coincidence rather than preserved ancient knowledge. Yet the level of detail challenges this explanation. Speculation typically produces generalized shapes, not specific geographical features that align with modern scientific discoveries. The river systems shown on Orontius Phineas's map, for instance, correspond closely to glacial valleys identified by contemporary Antarctic research. The coastal indentations match known features of Antarctica's actual shoreline. Such precision seems to exceed what pure speculation could achieve. Charles Hapgood, the controversial American professor who championed the theory of ancient maps, argued that these documents preserve knowledge from a time when Antarctica was indeed ice-free. His theory of crustal displacement suggested that the Earth's crust could shift rapidly, moving Antarctica from a temperate zone to its current polar position. Such a shift, Hapgood proposed, could have occurred within human memory, allowing advanced ancient civilizations to map the continent before it became frozen. Mainstream geology has largely rejected Hapgood's crustal displacement theory, but aspects of his observations about Antarctic ice remain intriguing. While the continent as a whole has been frozen for millions of years, evidence suggests that significant portions may have been ice-free much more recently than previously believed. Some regions of Antarctica experience occasional ice-free periods even today, and paleoclimatic research indicates that certain coastal areas may have remained habitable much longer than the overall continental freeze would suggest. The possibility of recent ice-free periods gains support from unexpected sources. Antarctic ice cores contain layers of dust and organic material that suggest periodic exposure of land surfaces. Geological surveys have revealed preserved forests and lake systems that appear to have existed far more recently than the conventional timeline would allow. Some researchers now propose that while Antarctica's interior has remained frozen for millions of years, coastal regions may have experienced cyclical periods of warming that left them temporarily habitable. Even more intriguing are the biological discoveries emerging from Antarctic research. Fossil evidence suggests that complex ecosystems persisted on the continent far longer than previously believed. Recent discoveries of preserved organic material, including what appears to be ancient human artifacts, have begun to challenge assumptions about when Antarctica became completely uninhabitable. While these findings remain controversial and often disputed, they suggest that the continent's history may be far more complex than simple models of continuous ice coverage. The ancient maps may thus preserve memories of Antarctica during one of these hypothetical ice-free periods. If portions of the continent remained habitable into recent millennia, or if earlier warming cycles created temporary windows of accessibility, advanced ancient civilizations might indeed have conducted surveys that were later preserved in cartographic form. The maps could represent not impossible knowledge, but knowledge from a time when the impossible had not yet become reality. Whether these maps truly show ice-free Antarctica or represent some other phenomenon entirely, they continue to challenge our understanding of both geological history and human capability. They suggest that the relationship between climate, geography, and civilization may be far more complex than modern science has yet unraveled. In their precise details and impossible accuracy, they whisper of worlds that existed beyond the edges of recorded history, worlds where continents wore different faces and humanity, perhaps, walked shores that now lie buried beneath eternal ice. The question haunts the margins of respectable archaeology like a persistent whisper. How did ancient peoples, supposedly limited to coastal navigation and primitive instruments, create maps of startling global accuracy? The conventional answer points to gradual accumulation of knowledge, skilled seamanship, and remarkable intuition. But as we examine the full scope of impossible cartography, a more unsettling possibility emerges, one that pushes the boundaries of historical plausibility into realms that make academics profoundly uncomfortable. Consider the mathematical precision required to create accurate world maps. Modern cartography depends on sophisticated understanding of spherical geometry, precise astronomical observation, and complex mathematical calculations. A mapmaker must understand longitude and latitude, comprehend the Earth's curvature, and possess instruments capable of measuring celestial positions with extraordinary accuracy. These requirements seem to exceed the technological capabilities of any known ancient civilization. Yet the maps exist. They show not just general continental shapes, but specific details that require precise surveying. The Dulcet-Portolan chart of 1339 depicts the Mediterranean with accuracy that wasn't surpassed until the 18th century. The Cantino map of 1502 shows newly discovered lands with detail that seems to exceed what contemporary explorers could have achieved. Most remarkably, various medieval maps show Antarctica, Australia, and other lands with features that wouldn't be officially documented for centuries. The technology required for such mapping presents a fundamental puzzle. Accurate longitude measurement essential for global cartography remained an unsolved problem until the development of precise chronometers in the 18th century. Even latitude measurement, though theoretically possible with ancient instruments, required sophisticated mathematical knowledge that historians believe was lost during Europe's Dark Ages. How could medieval mapmakers achieve accuracy that eluded their Renaissance successors? Some researchers propose that ancient civilizations possessed navigational technologies that have since been lost. The Polynesian navigators of the Pacific developed extraordinarily sophisticated wayfinding techniques using star patterns, wave formations, and migratory bird behavior. Their mental maps allowed them to navigate thousands of miles of open ocean with accuracy that impressed modern sailors. Perhaps other ancient cultures developed similar techniques that left no archaeological record, but were preserved in cartographic form. Archaeological evidence hints at advanced ancient technologies in other fields. The Antikythera mechanism demonstrates computational abilities that weren't officially redeveloped until medieval times. Roman concrete has proven more durable than modern equivalents. Ancient metallurgy produced Damascus steel with properties that modern science struggles to replicate. Perhaps sophisticated navigation and mapping techniques represent another lost ancient technology, preserved in maps but forgotten in practice. The astronomical knowledge displayed in ancient monuments suggests capabilities that conventional history overlooks. Stonehenge aligns with celestial events with mathematical precision. The Great Pyramid encodes the Earth's dimensions in its proportions. Mayan calendars demonstrate understanding of cosmic cycles that extends far beyond basic agricultural needs. Such knowledge could have supported advanced navigation and global surveying that left cartographic rather than architectural records. Yet even accepting the possibility of advanced ancient navigation, the scope of knowledge displayed in impossible maps stretches credibility. The accurate depiction of Antarctica's ice-free coastline, if authentic, requires either time travel or geological surveys conducted during periods when the continent was supposedly uninhabitable. The mathematical sophistication of certain map projections exceeds what any known ancient civilization achieved in other fields. The global scope of accurate geographical knowledge seems to require resources and organization beyond ancient capabilities. This is where the most unsettling theories emerge. If human civilization alone cannot account for the knowledge preserved in ancient maps, what other possibilities exist? The ancient astronaut hypothesis, popularized by writers like Erich von Däniken, suggests that advanced extraterrestrial visitors provided technological knowledge to early human civilizations. Such intervention could explain the sudden appearance of sophisticated mapping techniques that seem to exceed natural human development. The theory finds circumstantial support in ancient texts and traditions. Sumerian accounts describe the Anunnaki, beings from the sky who brought civilization to humanity. Biblical accounts mention the Nephilim, giants who possessed extraordinary knowledge. Hindu texts describe Vimanas, flying vehicles used by godlike beings. While mainstream scholarship interprets these as mythological rather than historical accounts, they could preserve cultural memories of actual contact with technologically advanced beings. Ancient art provides additional puzzles. Egyptian hieroglyphs occasionally depict objects that resemble modern aircraft or spacecraft. Mayan carvings show figures in what appear to be mechanical devices. Rock paintings worldwide depict humanoid beings with unusual characteristics, elongated skulls, advanced tools, or association with sky phenomena. While conventional interpretation sees these as symbolic or mythological representations, they could record actual encounters with non-human intelligence. The precision of ancient astronomical knowledge particularly supports intervention theories. The Dogon people of Mali possessed detailed knowledge of Sirius B, a white dwarf star invisible without telescopic aid, centuries before European astronomers detected it. They described the star's orbital period and characteristics with accuracy that modern astronomy has confirmed. How could an African tribe possess such knowledge without technological assistance or instruction from beings who possessed such technology? If advanced extraterrestrial visitors did interact with ancient humans, providing geographical knowledge would serve obvious purposes. Accurate maps would facilitate global exploration, resource location, and establishment of civilizations in optimal locations. The knowledge could have been provided directly through instruction or indirectly through technology that enabled ancient peoples to conduct their own global surveys. The intervention hypothesis also explains the apparently sudden disappearance of advanced ancient knowledge. If extraterrestrial contact ceased, or if the beings departed, the technological capabilities they provided would gradually degrade. Sophisticated mapping techniques would be reduced to copied documents whose original methods were no longer understood. This degradation pattern matches what we observe in ancient cartography: extremely accurate early maps followed by increasingly inaccurate copies as the original knowledge was lost. Yet the extraterrestrial hypothesis faces obvious limitations. No undisputed physical evidence of ancient alien contact has been discovered. The technologies required for interstellar travel remain theoretical, even for modern science. The motivation for alien intervention in human development remains speculative. Most significantly, accepting extraterrestrial influence requires abandoning conventional frameworks for understanding human history and capability. Perhaps the truth incorporates elements of multiple explanations. Ancient humans may have possessed technological capabilities that conventional archaeology has overlooked. Natural phenomena, unusual atmospheric conditions, geological processes, or astronomical events might have provided temporary advantages for navigation and surveying. Cultural transmission could have preserved geographical knowledge across millennia, maintaining accuracy through oral tradition and ritual practice, even when the original survey methods were forgotten. The ancient maps may also represent something entirely different from what we imagine. Rather than records of physical exploration, they might preserve knowledge gained through consciousness-altering practices, shamanic journeys, or other non-physical means of obtaining information. Many traditional cultures report geographical knowledge gained through dreams, visions, or spiritual communication with natural forces. Such knowledge, while not obtained through conventional exploration, could still accurately reflect physical reality. Whether the impossible maps preserve the legacy of advanced ancient mariners, extraterrestrial visitors, lost technologies, or entirely unknown methods of gaining geographical knowledge, they continue to challenge our understanding of human capability and historical development. They suggest that the relationship between consciousness, technology, and knowledge may be far more complex than modern science acknowledges. In their precise lines and impossible accuracy, they whisper of possibilities that extend far beyond the comfortable boundaries of conventional history. Paris, 1531. In the workshops near the Seine, where the finest craftsmen of Renaissance France pursued their trades, Arotius Phineas bent over his great work. As royal professor of mathematics at the Collège de France, Phineas commanded respect for his expertise in astronomy, geometry, and the emerging science of cartography. His world map, titled Nova et Integra Universi Orbis Descriptio, would represent the pinnacle of geographical knowledge in the early 16th century. Yet when modern researchers examine this map, they discover knowledge that seems to transcend not only Phineas's era, but any period in recorded human history. The map itself is a masterwork of Renaissance cartography, executed with mathematical precision and artistic elegance. Phineas employed a cordiform, heart-shaped projection that demonstrates sophisticated understanding of spherical geometry. His depiction of known lands, Europe, Africa, Asia, and the recently discovered Americas, reflects the finest geographical knowledge available to European scholars of his time. But it is his depiction of unknown lands that transforms the map from historical curiosity to inexplicable mystery. In the southern reaches of his world map, Phineas draws a continent he labels Terra Australis, the southern land. This was not unprecedented. Classical geographers had long theorized about southern continents necessary to balance the Earth's northern landmasses. What makes Phineas's depiction extraordinary is not its existence, but its accuracy. When compared with modern satellite mapping of Antarctica, His Terra Australis reveals correspondences that seem to exceed the realm of coincidence. The continent's overall shape in Phineas's map closely matches Antarctica's actual outline. The proportions, the relationship between length and width, the general configuration all align remarkably well with modern knowledge. But the correspondences extend far beyond general shape. Phineas shows specific geographical features that wouldn't be detected until the development of modern Antarctic research techniques 4 centuries later. The map depicts Antarctica crossed by a mountain range that divides the continent into distinct regions. Modern geological surveys have confirmed that the Transantarctic Mountains create exactly such a division, separating East and West Antarctica with a barrier of peaks that extends across the entire continent. Phineas shows this mountain system in approximately correct position, running from the Ross Sea region to what we now know as the Weddell Sea area. Even more remarkable are the coastal details. Phineas's map shows numerous bays, inlets, and peninsular features along Antarctica's shoreline. When researchers in the 1960s began comparing these details with modern surveys of Antarctica's actual coast, they discovered correspondences that seemed statistically impossible. The shapes and positions of coastal indentations, the locations of major geographical features, even the proportional relationships between different sections of coastline all matched with accuracy that systematic surveying should have been required to achieve. The map also depicts what appear to be river systems flowing across the interior of the Antarctic continent. To 16th century eyes, this would have seemed natural. Any habitable continent should have rivers. But modern research has revealed that beneath Antarctica's ice sheet lie preserved river valleys, ancient waterways that flowed when portions of the continent were ice-free. The positions and patterns of rivers shown on Phineas's map correspond closely to these buried valley systems, as if he had somehow mapped the continent's drainage patterns before they became frozen beneath miles of ice. Perhaps most intriguingly, the map shows the continent as largely ice-free, with only limited areas of what appear to be glacial coverage. The coastlines are drawn as exposed land, with clear definition between water and shore. If this representation is accurate, it depicts Antarctica as it would appear without its current ice sheet, a view that no human civilization should have been capable of achieving according to conventional understanding of both geological and human history. Phineas himself provides few clues about his sources for this remarkable geographical knowledge. Unlike Piri Reis, who detailed his compilation process and listed his source materials, Phineas offers little documentation about how he obtained information about Terra Australis. His other works demonstrate deep familiarity with classical geographical texts, medieval Arabic treatises, and contemporary Portuguese navigation reports. But none of these known sources could account for the specific accuracy of his Antarctic depiction. The mathematical sophistication required to create Phineas's map suggests access to advanced geographical knowledge. The cordiform projection he employed requires understanding of spherical trigonometry and considerable computational skill. More significantly, accurately depicting Antarctica's relationship to other continents requires knowledge of the Earth's true dimensions and the precise positions of landmasses on a global scale. Such knowledge supposedly didn't exist in complete form until much later in the Renaissance. Modern analysis has revealed additional puzzles in the map's construction. The projection appears to be centered on a point that optimizes the accuracy of the Antarctic depiction, suggesting that the southern continent was a primary focus of the mapmaker's attention rather than a speculative addition. The mathematical relationships between different continental landmasses demonstrate understanding of global geography that seems to exceed what 16th century exploration had achieved. Skeptical researchers have proposed various conventional explanations for the map's accuracy. Some suggest that Phineas extrapolated southern landmasses from classical sources, particularly Ptolemy's theoretical discussions of continental balance. Others propose that the accuracy results from coincidental speculation that Phineas made educated guesses about southern geography that accidentally approximated reality. Still, others argue that later copies of the map may have been modified to incorporate knowledge gained after 1531. Yet these explanations struggle to account for the specific accuracy of geographical details. General speculation might produce approximately correct continental shapes, but it seems unlikely to generate precise coastal features, accurate mountain placements, and correct river system patterns. The level of detail suggests access to systematic geographical surveys rather than theoretical speculation. The mystery deepens when Phineas' map is compared with other examples of impossible cartography from the same period. Maps by Mercator, Ortelius, and other Renaissance cartographers show similar accuracy in depicting unknown lands, suggesting that multiple mapmakers had access to geographical knowledge that conventional history cannot explain. The consistency of these depictions across different sources and different time periods argues against coincidental accuracy. Whether Phineas's map preserves ancient knowledge of ice-free Antarctica, represents some unknown method of geographical surveying, or documents something entirely beyond current understanding, it continues to challenge assumptions about the limits of Renaissance knowledge and human historical capabilities. The map stands as testimony that geographical knowledge of extraordinary scope and precision circulated in the 16th century knowledge, whose origins and methods remain as mysterious today as they were nearly 5 centuries ago when Orontius Phineas first set compass to parchment and revealed a continent that officially did not yet exist. In the dialogues of Plato, written in 4th century Athens, lies perhaps the most famous account of a lost continent in all of human literature. Atlantis emerges from his pen not as fantasy, but as historical account. A great island civilization that existed beyond the Pillars of Hercules, possessed of advanced technology and maritime power, that vanished beneath the waves in a single day and night of geological catastrophe. For over 2 millennia, scholars have debated whether Plato's Atlantis represents philosophical allegory or preserved historical memory. But Atlantis is far from unique in the annals of human tradition. Across cultures and continents, in myths separated by vast distances and millennia of time, we find recurring accounts of vanished lands, sunken continents, and lost civilizations that once commanded the seas. The universality of these accounts suggests something deeper than mere coincidental imagination. From the Pacific Islands to the Mediterranean, from ancient India to pre-Columbian America, human cultures have preserved stories of lands that once existed but now lie beneath the waves or beyond accessible borders. These myths share remarkable similarities, despite their geographical and temporal separation similarities that hint at possible common origins in historical events that transcended local experience. Hindu and Buddhist traditions speak of Kumari Kandam, a vast continent that supposedly connected India with Australia and extended far into the southern Indian Ocean. According to Tamil literary sources, this landmass supported advanced civilizations for thousands of years before being gradually submerged by rising seas. The accounts describe sophisticated cities, advanced technology, and maritime empires that controlled vast stretches of the Indian Ocean. While mainstream archaeology finds no evidence for such a continent, geological research has revealed that sea levels were indeed much lower during recent ice ages, and that substantial land areas in the region are now submerged. The traditions become more intriguing when compared with modern geological understanding. The Indo-Australian plate shows evidence of significant geological activity in relatively recent times. Underwater surveys have revealed extensive submerged landmasses between India and Australia, some showing what appear to be constructed features that could represent ancient coastal settlements. The mythical Kumari Kandam may preserve cultural memories of lands that were indeed habitable before post-glacial sea level rise submerged them beneath the Indian Ocean. Aboriginal Australian traditions speak of lands that connected their continent with New Guinea and other islands during the Dreamtime, the mythological period when Ancestral spirits shaped the world. These accounts describe vast plains where now only ocean exists, islands that could be reached on foot, and coastal regions that extended far beyond present shorelines. Archaeological evidence confirms that during the last ice age, lower sea levels did create land bridges between Australia and New Guinea, and that extensive coastal plains existed around what is now northern Australia. The Aboriginal accounts may preserve 40,000-year-old memories of geographical conditions that modern science has only recently reconstructed. Pacific Islander traditions throughout Polynesia and Melanesia contain accounts of Mu or Lemuria, a vast Pacific continent that supported advanced civilizations before its destruction. These traditions describe not only the continent's existence, but specific details about its geography, culture, and technology. The accounts speak of great cities, sophisticated agriculture, and maritime knowledge that allowed navigation across vast ocean distances. While no geological evidence supports the existence of a large Pacific continent in recent times, the traditions may preserve memories of now submerged islands and land areas that were more extensive when sea levels were lower. Norse mythology preserves accounts of lands beyond the known world, including references to continents across western seas. The Vinland sagas describe voyages to lands that match descriptions of North America, but they also contain references to other lands, some described as existing beyond Vinland, others as having vanished beneath ice or water. These accounts may preserve memories of Arctic lands that were accessible during warmer periods, or of subarctic regions that became uninhabitable as climate changed. Perhaps most intriguingly, Native American traditions across North and South America contain numerous accounts of previous worlds that were destroyed by floods, earthquakes, or other catastrophes. Hopi traditions describe multiple previous worlds that ended in destruction, with survivors carrying knowledge into new eras. Mayan texts speak of previous creations that were destroyed and renewed. These accounts often include specific geographical details about lands and seas that existed in previous worlds, details that sometimes correspond to geological conditions that existed in earlier periods of Earth's history. The flood myths found in cultures worldwide have traditionally been interpreted as memories of local disasters or metaphorical accounts of spiritual transformation. But when examined collectively, they show patterns that suggest possible common origins in global or near-global events. The timing described in various flood accounts, when adjusted for different calendrical systems, often converges around periods that correspond to known episodes of rapid climate change and sea level rise at the end of the last ice age. Geological research has begun to provide context for understanding how lost continent myths might preserve historical memories. The end of the last ice age, approximately 12,000 years ago, involved rapid melting of continental ice sheets and corresponding rises in sea level of over 120 meters. This process submerged vast coastal areas where human populations likely concentrated. Entire continental shelves that had been exposed as habitable land disappeared beneath rising seas within relatively short geological time periods. The process wasn't uniform across the globe. Some regions experienced rapid submersion, while others saw gradual retreat of coastlines over centuries or millennia. Coastal populations would have been forced to migrate repeatedly as their homelands disappeared beneath advancing waves. The trauma of such massive geographical changes would naturally become embedded in cultural memory, passed down through oral traditions that might preserve details about the lost lands with remarkable accuracy. Recent underwater archaeology has begun to discover evidence that supports aspects of these traditional accounts. Submerged cities have been found off the coasts of India, Japan, and the Mediterranean. Underwater structures that appear to be human-made have been detected on continental shelves around the world. While these discoveries don't confirm the existence of advanced ancient civilizations, they do demonstrate that human settlements existed on lands that are now beneath the sea. The relationship between myth and geology becomes even more complex when we consider the possibility that some lost continents may not be lost at all, but simply inaccessible or unknown to modern civilization. The Antarctic continent, for instance, remained unknown to official exploration until the 19th century, yet it appears on maps dating centuries earlier. Could other large land masses exist in remote regions of the planet, perhaps ice-covered or otherwise hidden from casual observation? Modern satellite surveys have mapped virtually every square kilometer of the Earth's surface, making the existence of unknown major landmasses extremely unlikely. But the possibility remains that significant lands existed in recent geological time that are now submerged or ice-covered. The mythological accounts may preserve accurate geographical knowledge about such lands, maintaining through oral tradition information that would otherwise be lost to historical record. Whether the lost continent myths preserve memories of actual geographical changes, represent symbolic accounts of cultural transformation, or document something entirely different, they demonstrate that human consciousness has long grappled with concepts of impermanence and change on a planetary scale. The myths suggest that human memory, encoded in story and tradition, may extend much further into the past than written history records. In their accounts of vanished lands and lost civilizations, they offer tantalizing hints that the world's geography and humanity's relationship with it may be far more dynamic and mysterious than our current understanding suggests. In a cluttered office at Keene State College in New Hampshire, Professor Charles Hutchins Hapgood bent over a collection of ancient maps that would consume the final decades of his career and challenge the fundamental assumptions of modern geology. The year was 1956, and Hapgood, a historian and geographer by training, had stumbled upon what he believed to be evidence of a lost chapter in human civilization. His students, initially recruited to help with routine research, found themselves participants in an investigation that would lead to one of the most controversial theories in 20th century earth science. Hapgood's academic credentials were respectable but unremarkable. He held degrees from Harvard and taught at various New England institutions, focusing primarily on the history of science and occasionally venturing into geological topics. Nothing in his background suggested preparation for the revolutionary conclusions that would emerge from his cartographic research. Yet it was perhaps this outsider's perspective that allowed him to see patterns that specialized experts had overlooked or dismissed. The investigation began innocuously enough. Hapgood had assigned his students to research ancient maps for a project on the history of geographical knowledge. They were examining copies of medieval and Renaissance charts when they noticed anomalies that couldn't be easily explained by conventional historical understanding. Maps showed lands with impossible accuracy. Coastlines appeared with precision that shouldn't have existed. Most puzzling of all, some maps seemed to depict geographical conditions that differed dramatically from modern reality. The Piri-Reis map became Hapgood's obsession. Working with his students, he subjected the 1513 Turkish chart to detailed mathematical analysis. They calculated the projection methods, measured distances and proportions, and compared the ancient depiction with modern geographical surveys. The results were startling. Not only did the map show remarkable accuracy for its supposed era, but it appeared to depict Antarctica without ice coverage, showing coastlines and geographical features that modern science believed had been buried under glacial ice for millions of years. Conventional explanations for the map's accuracy seemed inadequate to Hapgood. How could a 16th century Ottoman admiral possess geographical knowledge that exceeded what European explorers achieved through centuries of systematic surveying? How could ancient cartographers know details about Antarctica's sea's coastline that were undiscovered until the 1950s International Geophysical Year surveys? The puzzles multiplied as Hapgood expanded his investigation to include other examples of anomalous ancient cartography. Driven by the mounting evidence of impossible geographical knowledge, Hapgood began to formulate a theory that would place him at odds with established geological science. If ancient maps truly showed ice-free Antarctica with accurate detail, then either the maps were forgeries, which examinations suggested they were not, or Antarctica had been ice-free at a time when ancient civilizations could observe and map it. But conventional geology insisted that Antarctica had been frozen for millions of years, long before human civilization developed. The solution, Hapgood proposed, lay in a mechanism that geology had overlooked: rapid displacement of the Earth's crust. Drawing upon earlier work by geologist Hugh Auchincloss Brown, Hapgood theorized that the planet's outer crust could shift as a unit over the underlying mantle, moving continents thousands of miles from their original positions in relatively short geological time periods. Such crustal displacement could move Antarctica from a temperate zone to its current polar position within human historical memory. The theory required extraordinary geological forces, but Hapgood believed he had identified the mechanism. The massive ice accumulation at the poles during ice ages could create imbalanced weight distribution that would eventually trigger rapid crustal movement. When the imbalance reached a critical point, the entire crust would shift to restore equilibrium, carrying continents to new positions and dramatically altering global climate patterns within decades or centuries rather than millions of years. Hapgood's crustal displacement theory offered explanations for numerous puzzles beyond ancient maps. It could account for evidence of tropical plants in Arctic regions, explain the extinction of mammoths and other Ice Age creatures, and provide a mechanism for rapid climate change that seemed to exceed what conventional theories could explain. The theory suggested that Earth's geography was far more dynamic and unstable than mainstream science believed. The academic reception of Hapgood's ideas was largely hostile. Geologists pointed out that crustal displacement on the scale Hapgood proposed would require forces far greater than ice accumulation could provide. The mechanism violated fundamental principles of physics and geology. No evidence existed for the kind of rapid, large-scale crustal movement that the theory required. Most damning of all, the geological record showed no signs of the global catastrophes that such displacement would necessarily produce. Yet Hapgood's work attracted attention from an unexpected source. Albert Einstein, in the final years of his life, became intrigued by the crustal displacement theory. Einstein wrote a preface for Hapgood's 1958 book, Earth's Shifting Crust, lending his prestigious name to the controversial theory. Einstein was particularly impressed by Hapgood's mathematical analysis of ancient maps in his arguments about ice accumulation at the poles. Though Einstein was not a geologist, his endorsement provided credibility that helped Hapgood's ideas reach wider audiences. Einstein's support proved to be both blessing and curse for Hapgood's theory. While it brought attention and respectability to the work, it also created expectations that the theory could not fulfill. When subsequent geological research failed to support crustal displacement mechanisms, Einstein's endorsement became more liability than asset. Critics pointed out that Einstein's expertise lay in theoretical physics rather than geology, and that his support reflected interest in novel ideas rather than evaluation of geological evidence. Modern plate tectonic theory, developed in the decades following Hapgood's initial work, has provided alternative explanations for many of the phenomena that inspired crustal displacement theories. Continents do move, but through well-understood mechanisms operating over millions of years rather than rapid displacement events. The geological evidence overwhelmingly supports gradual rather than catastrophic crustal movement, making Hapgood's rapid displacement theory untenable in its original form. Yet aspects of Hapgood's work have proven more durable than his theoretical framework. His detailed analysis of ancient maps remains valuable, even if his explanations for their accuracy have been superseded. His demonstration that ancient cartographers possessed sophisticated geographical knowledge continues to puzzle researchers, even without invoking crustal displacement to explain it. Most significantly, his work opened new avenues for investigating the relationship between ancient knowledge and modern understanding. Hapgood's legacy extends beyond his specific theoretical contributions. His willingness to challenge established paradigms, his meticulous analysis of historical evidence, and his integration of multiple disciplines demonstrated approaches that continue to influence alternative historical research. Though his crustal displacement theory has been largely rejected by mainstream science, his broader investigation of ancient knowledge and lost civilizations has inspired generations of researchers who continue to explore the mysteries he first brought to widespread attention. The story of Charles Hapgood illustrates both the promise and perils of revolutionary thinking in science. His maps research uncovered genuine mysteries that conventional explanations struggle to address. His theoretical solutions, while ultimately unsuccessful, demonstrated the importance of considering radical alternatives when conventional approaches prove inadequate. Most importantly, his work established that ancient civilizations possess geographical knowledge of scope and accuracy that historians and geographers are still working to understand and explain. In the outer reaches of alternative geography theory, beyond the comfortable boundaries of mainstream science, and even beyond the speculative territories of lost civilization, research lies a concept so radical that it challenges not merely our understanding of the past, but our basic assumptions about the present world itself. It is the theory that our familiar geography represents only a portion of a much larger planetary surface, that beyond the frozen barriers of Antarctica lies not merely ice and ocean, but additional continents, unknown landmasses that exist in dimensions of space that conventional mapping has never explored. The idea emerges from careful analysis of ancient maps that seem to show more than they should. While researchers like Charles Hapgood focused on the accuracy of known geographical features, other investigators have noticed something potentially more significant: the presence of landmasses that don't correspond to any known geography. Regions that appear to extend beyond the boundaries of our familiar world into territories that official exploration has never reached. These maps don't just show Antarctica without ice. They show lands beyond Antarctica, continents that exist in directions that modern geography insists contain only ocean. The phenomenon appears across multiple ancient sources. Medieval maps often show southern landmasses that extend far beyond what we recognize as Antarctica. Renaissance charts depict continental systems that seem too large and complex to represent merely ice-free versions of known continents. Most intriguingly, some of these maps suggest that what we call Antarctica may not be a continent surrounded by ocean, but rather a barrier or boundary that separates our familiar world from larger geographical systems beyond. Consider the implications if such maps represent accurate knowledge rather than speculative fantasy. Our understanding of Earth's geography depends upon exploration and mapping efforts that have focused primarily on accessible regions, lands reachable by conventional navigation and exploration techniques. But what if significant portions of the planetary surface remain inaccessible, not because they are impossible to reach, but because they lie beyond barriers that conventional exploration has never successfully crossed? Antarctica itself presents puzzles that support such speculation. Despite decades of intensive research and exploration, vast regions of the continent remain essentially unknown. The harsh climate, extreme isolation, and technical challenges of Antarctic exploration have limited detailed investigation to relatively small areas near research stations and accessible coastal regions. Military restrictions and international treaties further limit the scope of exploration, creating vast territories that remain off-limits to civilian investigation. Modern satellite imaging would seem to eliminate the possibility of unknown major landmasses. But satellite coverage itself depends upon assumptions about planetary dimensions and orbital mechanics that might not account for geographical features that exist beyond conventional spatial boundaries. If additional continents exist in regions that satellites cannot observe, either due to atmospheric conditions, magnetic field effects, or more exotic possibilities, then our satellite-based understanding of global geography might be incomplete despite appearing comprehensive. The ice wall theory suggests that Antarctica functions not as a continent in the conventional sense, but as a massive barrier of ice that encircles the known world and separates it from additional territories beyond. This concept challenges fundamental assumptions about planetary structure and geography, proposing that our familiar continents and oceans represent only the central portion of a much larger surface area. Beyond the Antarctic ice barrier, according to this theory, lie additional continents, different climate zones, and possibly even separate civilizations that exist outside the geographical framework of conventional understanding. Historical accounts provide intriguing support for such possibilities. Early Antarctic explorers reported anomalous observations that don't fit standard geographical models. Some described lands beyond the ice that seemed to extend indefinitely in directions that should contain only ocean. Others reported unusual atmospheric conditions, magnetic anomalies, and navigational difficulties that suggested they were encountering geographical features unlike anything in their experience or training. Admiral Richard Byrd's Antarctic expeditions, particularly his flights over the polar regions in the 1940s and 1950s, produced reports that have fueled speculation about unknown lands beyond the ice. Byrd described seeing green landscapes, flowing rivers, and what appeared to be temperate regions and areas where only ice should exist. While conventional explanations interpret these as navigational errors or atmospheric optical effects, some researchers suggest that Byrd may have observed actual geographical features that exist beyond the boundaries of mapped Antarctica. The concept gains additional support from ancient traditions and mythological accounts that describe worlds beyond the known regions of human habitation. Norse mythology speaks of lands beyond the ice, regions that exist past the frozen barriers that mark the edges of familiar geography. Hindu and Buddhist cosmology describes multiple worlds and dimensional realms that exist beyond ordinary human perception. These traditions might preserve knowledge of actual geographical territories, rather than merely spiritual or metaphorical concepts. Military and government secrecy surrounding Antarctic exploration adds another layer of mystery to the possibility of unknown lands. International treaties restrict civilian access to vast areas of Antarctica, officially for environmental protection, but potentially for other reasons. Military operations in polar regions remain classified, and government research programs often produce results that are not shared with civilian scientists. If significant geographical discoveries have been made in restricted areas, public knowledge of global geography might be deliberately incomplete. The physics of such hidden continents presents challenges, but not impossibilities. If additional landmasses exist beyond conventional geographical boundaries, they might be accessible through routes that don't appear on standard maps, passages through ice formations, underwater channels, or even dimensional gateways that exist at specific geographical locations. Ancient maps that show such regions might preserve knowledge of navigation routes that have been forgotten or deliberately concealed. Climate patterns in such hidden regions could differ dramatically from familiar geographical zones. Areas beyond the Antarctic barrier might experience different seasonal cycles, alternative weather patterns, or even completely different environmental conditions than those observed in known territories. Such regions could support ecosystems, resources, and possibly civilizations that exist entirely outside the framework of conventional geographical and biological understanding. The technological implications of discovering additional continents would be profound. New landmasses could contain mineral resources, energy sources, and biological systems that would revolutionize human understanding of planetary possibilities. Contact with civilizations that developed in isolation from known historical patterns could provide insights into alternative paths of cultural and technological development. Most significantly, the existence of hidden continents would require fundamental revision of scientific models about planetary structure, geography, and the nature of physical reality itself. Whether the ancient maps that hint at continents beyond the ice wall preserve accurate geographical knowledge or represent some other form of information entirely, they continue to challenge assumptions about the completeness of our geographical understanding. They suggest that the familiar world of conventional maps and satellite imagery might represent only a portion of the full planetary surface, available for exploration and habitation. In their precise details and impossible implications, they whisper of possibilities that extend far beyond the comfortable boundaries of known geography into realms that await rediscovery by future generations of explorers, willing to venture past the edges of conventional understanding. Across the medieval and Renaissance maps of Europe lie scattered dozens of islands that shouldn't exist, drawn with careful precision, marked with names and detailed coastal features. These phantom islands appeared on navigational charts for centuries before mysteriously vanishing from cartographic record. They bore names like Hy-Brasil, Antillia, and the Isle of Demons. Mariners reported sighting them, navigators calculated their positions, and cartographers included them in the most authoritative maps of their eras. Then, as navigation techniques improved and exploration became more systematic, these islands began to disappear, not through geological catastrophe, but through the simple fact that they could no longer be found. The phenomenon of phantom islands represents one of cartography's most persistent mysteries. Unlike the impossible accuracy of ancient maps showing real but undiscovered lands, phantom islands present the opposite puzzle. Why did skilled mapmakers consistently include geographical features that apparently never existed? The conventional explanation suggests errors in navigation, misidentification of known lands, or deliberate deception by explorers seeking to enhance their discoveries. Yet the consistency and persistence of these phantom islands across multiple sources and centuries suggests something more complex than simple mistakes or fraud. Hy-Brasil provides perhaps the most famous example of phantom island persistence. This circular island, supposedly located west of Ireland, appeared on European maps from the 14th through the 19th centuries. Medieval Irish traditions placed it in the Western Ocean, describing it as a land of eternal youth, accessible only to the pure of heart. Later maps positioned it more precisely, showing it as a substantial island, roughly circular in shape, sometimes divided by a river or channel running east to west. The island was substantial enough that several expeditions were mounted specifically to locate and colonize it, yet none ever returned with definitive proof of its existence. The cartographic treatment of Hy-Brasil evolved over time in ways that suggest mapmakers had access to detailed information about its supposed geography. Early depictions showed it as a simple circular island, but later versions included coastal features, inland topography, and even settlements. Some maps showed it connected to other phantom islands by underwater ridges or seasonal land bridges. The level of geographical detail seems inconsistent with pure fantasy, yet systematic searches failed to locate any land in the positions where maps consistently placed it. Antillia, the Isle of Seven Cities, presents another enduring phantom island mystery. Portuguese charts from the 15th century show it as a large rectangular island in the Atlantic, positioned roughly halfway between Europe and the Americas. According to legend, 7 Portuguese bishops fled the Moorish invasion of Iberia in the 8th century, each founding a city on this remote Atlantic island. The legend provided both historical context and geographical specificity that made Antillia seem plausible to Renaissance explorers. Columbus himself may have been seeking Antillia when he encountered the Caribbean islands that he initially mistook for Asian territories. The geographical consistency of phantom islands across different mapmakers and time periods suggests that their inclusion wasn't arbitrary. Hy-Brasil consistently appeared at approximately the same coordinates relative to Ireland. Antillia maintained similar proportions and orientation across different charts. The Isle of Demons, reported by French explorers in the North Atlantic, appeared in roughly consistent positions relative to Newfoundland. Such consistency implies that mapmakers were drawing from common sources rather than inventing features independently. Some phantom islands may represent real lands that existed temporarily or seasonally. Submarine volcanic activity can create islands that emerge and submerge over relatively short time periods. Ice formations in polar regions can create temporary landmasses that appear solid to distant observers, but melt or shift position with changing seasons. Fog banks and atmospheric conditions can create optical illusions that make clouds or distant lands appear as nearby islands. Such phenomena could explain how multiple observers might report similar geographical features that later investigations cannot locate. The possibility of temporary islands gained support from modern geological understanding of seafloor volcanism and tectonic activity. Mid-ocean ridges regularly produce new islands through volcanic eruptions, many of which are subsequently eroded by wave action or submerged by changes in sea level. The Azores, Iceland, and other Atlantic islands represent permanent examples of such volcanic island formation. But many similar formations may have existed temporarily without leaving permanent traces. Historical accounts of phantom island sightings often include details that suggest real encounters rather than pure imagination. Sailors reported specific coastal features, noted weather patterns around the islands, and sometimes claimed to have landed and explored interior regions. These accounts, while unverifiable by later investigation, contain the kind of mundane detail that typically accompanies genuine exploration reports rather than fictional narratives. Some researchers propose that phantom islands preserve memories of lands that existed during earlier periods, when sea levels were lower. During ice ages, when vast amounts of ocean water were locked in continental glaciers, sea levels dropped by over 100 meters below current levels. This exposed vast areas of continental shelf that are now submerged, creating archipelagos and islands in regions that are now open ocean. Cultural memories of such lands, passed down through oral tradition, might have influenced medieval mapmakers who incorporated traditional geographical knowledge into their charts. A systematic disappearance of phantom islands from maps coincided with improvements in navigation technology and exploration techniques. As chronometers allowed precise longitude determination and systematic surveying replaced casual observation, the geographical features that couldn't be consistently relocated were gradually removed from official charts. This process suggests that the phantom islands resulted from limitations in navigation and observation rather than deliberate deception or pure fantasy. Yet some phantom islands showed remarkable persistence, even in the face of systematic attempts to locate them. Hy-Brasil continued to appear on maps well into the 19th century, long after navigation techniques had improved sufficiently to detect any substantial island in its supposed location. The Aurora Islands in the South Atlantic were reported by multiple expeditions in the 18th and 19th centuries, with detailed descriptions of their coastal features and positions. Yet systematic searches in the 20th century found only open ocean. Modern satellite surveys and ocean floor mapping have provided definitive answers about most historical phantom island locations. No substantial landmasses exist in the positions where maps consistently placed features like Hy-Brasil, Antillia, or the Isle of Demons. Ocean depth measurements confirm that no shallow areas or submerged islands exist that could account for historical sightings. The phantom islands appear to have been truly phantom geographical features that existed in human perception and cartographic tradition, but not in physical reality. Yet the phenomenon raises deeper questions about the relationship between perception, tradition, and geographical knowledge. How did detailed geographical information about non-existent islands persist for centuries across multiple sources? Why did skilled navigators consistently report lands in positions where no lands exist? What mechanisms allowed phantom islands to maintain consistent geographical characteristics across different observers and time periods? The answers may lie not in conventional geography, but in the complex ways that human consciousness interacts with environment and expectation. Phantom islands might represent collective, psychological phenomena, shared expectations that influenced observation and interpretation of ambiguous sensory data. Cultural traditions about distant lands might have created perceptual frameworks that encouraged observers to interpret atmospheric effects, cloud formations, or distant real lands as nearby islands that match traditional descriptions. Whether phantom islands resulted from navigation errors, temporary geological phenomena, psychological effects, or something entirely outside conventional understanding, they demonstrate that the relationship between human knowledge and geographical reality is far more complex than simple mapping and exploration might suggest. In their mysterious appearances and systematic disappearances, they remind us that even our most confident geographical knowledge rests upon foundations of perception and interpretation that may be less solid than we assume. In the remote highlands of Malai, far from the centers of Western learning, the Dogon people have maintained for centuries an astronomical tradition that defies conventional understanding of how isolated cultures acquire cosmic knowledge. Their creation myths speak with startling precision about Sirius B, a white dwarf star invisible to the naked eye that orbits the bright star Sirius in our night sky. They describe its 50-year orbital period with accuracy that modern astronomy has confirmed. They know its extraordinary density, understand its relationship to its visible companion, and incorporate this knowledge into religious ceremonies that may be thousands of years old. How did an African tribe acquire detailed information about stellar objects that Western science didn't discover until the 20th century? The Dogon mystery extends beyond astronomical knowledge to encompass geographical understanding that seems to transcend their isolated location in West Africa. Their traditions speak not only of distant stars, but of distant lands, describing continents and ocean systems with accuracy that suggests either extensive ancient contact with global civilizations or access to geographical knowledge through means that conventional anthropology cannot explain. The parallel between their impossible astronomical knowledge and their sophisticated geographical understanding suggests that both may derive from the same mysterious source. The connection between celestial and terrestrial mapping runs deeper than casual observation might suggest. Ancient civilizations consistently linked astronomy with geography, understanding that precise knowledge of stellar positions and movements was essential for accurate navigation and mapping of earthly territories. The same mathematical and observational skills required to track celestial objects across the sky were necessary to maintain accurate positions while crossing vast ocean distances. Stellar navigation provided the technological foundation that made global exploration and mapping possible in ages before mechanical instruments and satellite systems. Egyptian astronomical texts demonstrate this integration of stellar and terrestrial knowledge. The pyramid texts incorporate detailed astronomical observations alongside geographical references that suggest knowledge of lands far beyond the Nile Valley. Temple inscriptions describe stellar alignments that correspond to specific earthly locations, as if the ancient Egyptians used astronomical knowledge to encode geographical information in their sacred architecture. The precision of pyramid construction, with its accurate cardinal alignments and incorporation of astronomical constants, demonstrates mathematical capabilities that could have supported both stellar observation and global surveying. Similar patterns appear in ancient Mesopotamian civilizations. Babylonian astronomical records show sophisticated understanding of planetary cycles and stellar positions that enabled accurate calendar systems and navigation techniques. Their geographical knowledge, preserved in cuneiform texts, describes lands and peoples far beyond the boundaries of Mesopotamian political control. Trade records mention exotic goods from regions that official history suggests were unknown to ancient Middle Eastern civilizations. The mathematical astronomy that enabled such accurate celestial observations could have provided the technological foundation for global exploration and mapping. The megalithic monuments of Europe reveal another dimension of the astronomy-geography connection. Stonehenge, Newgrange, and other stone circles demonstrate precise astronomical alignments that required sophisticated mathematical knowledge and long-term observational programs. But these monuments also show geographical relationships that suggest their builders possessed accurate knowledge of distances and directions across vast territories. The alignment patterns between different monument sites indicate a coordinate system that spans the European continent, suggesting that megalithic cultures possessed surveying capabilities that conventional archaeology attributes to much later civilizations. Polynesian navigation traditions provide the clearest example of how astronomical knowledge enables geographical exploration. Pacific Island navigators developed techniques for crossing thousands of miles of open ocean using only observations of stars, waves, and wildlife behavior. Their mental maps integrated stellar positions with ocean currents, seasonal weather patterns, and island positions to create navigation systems of extraordinary accuracy and reliability. These techniques enabled the settlement of islands scattered across a third of the planet's surface, demonstrating that sophisticated astronomical knowledge could indeed support global geographical exploration. The accuracy of ancient astronomical knowledge raises profound questions about how such information was obtained and preserved. The doggone understanding of Sirius B requires not only telescopic observation, but also long-term systematic record keeping to determine orbital periods and stellar characteristics. No known ancient African civilization possessed the technological infrastructure that conventional astronomy considers necessary for such observations. Yet the knowledge exists, preserved in oral tradition with accuracy that modern instruments have confirmed. Similar puzzles appear in other ancient astronomical traditions. Mayan calendars demonstrate understanding of planetary cycles that extends far beyond practical agricultural or ceremonial needs. Their Venus tables calculate the planet's synodic period with accuracy that rivals modern measurements. Their long count calendar incorporates cosmic cycles spanning millions of years, suggesting mathematical concepts that seem to exceed the requirements of any earthly civilization. Such sophisticated astronomical knowledge could certainly have supported global navigation and geographical surveying. If ancient Mayan civilization possessed the maritime technology to conduct such exploration, Hindu astronomical texts describe cosmic cycles and stellar positions with mathematical precision that suggests systematic observational programs spanning millennia. The Surya Siddhanta, an ancient Sanskrit astronomical treatise, calculates the Earth's circumference, the distances between celestial bodies, and the duration of various cosmic cycles with accuracy that was unachieved by European astronomy until much later periods. Such sophisticated astronomical knowledge could have enabled global geographical exploration and mapping. If ancient Hindu civilizations possessed the technological and organizational capabilities for such endeavors, the relationship between astronomical knowledge and geographical understanding becomes even more intriguing when we consider the possibility that both derive from non-human sources. If advanced extraterrestrial civilizations provided astronomical information to ancient human cultures, they might simultaneously have provided geographical knowledge that enabled global exploration and mapping. The same technological capabilities required for interstellar travel would certainly be adequate for comprehensive planetary surveying and astronomical observation. Ancient texts often describe the acquisition of astronomical and geographical knowledge through contact with divine beings or sky gods who possessed superior wisdom. While conventional scholarship interprets these as mythological accounts, they might preserve cultural memories of actual contact with technologically advanced beings who provided both stellar and terrestrial information to developing human civilizations. Such contact could explain how isolated cultures like the Dogon acquired impossible astronomical knowledge while also accounting for the Sophisticated geographical understanding preserved in ancient maps. The integration of astronomical and geographical knowledge also suggests alternative methods of information acquisition that don't depend on physical exploration. Many traditional cultures report obtaining geographical knowledge through shamanic practices, visionary experiences, and consciousness-altering techniques that provide direct access to information about distant locations. If consciousness can indeed access geographical information through non-physical means, then the same techniques might also provide astronomical knowledge, explaining how ancient cultures acquired accurate information about both terrestrial and celestial phenomena. Modern research into consciousness and remote viewing has documented cases where individuals appear to acquire accurate information about distant locations through mental processes alone. If such capabilities are genuine and were more developed in ancient cultures, they could account for both the sophisticated geographical knowledge preserved in impossible maps and the accurate astronomical information maintained by cultures like the Dogon. The parallel accuracy of ancient stellar and terrestrial knowledge might reflect not technological achievement, but consciousness capabilities that conventional science is only beginning to investigate. Whether ancient astronomical and geographical knowledge derived from advanced technology, extraterrestrial contact, consciousness-based information acquisition, or entirely unknown methods, the consistent parallel between stellar and terrestrial accuracy suggests that both forms of knowledge may share common origins in sources that transcend conventional understanding of ancient human capabilities. In their impossible precision and mysterious origins, ancient star maps and earth maps continue to challenge our assumptions about the relationship between consciousness, technology, and knowledge itself. In the basement of Yale University's Beinecke Library, carefully preserved behind climate-controlled glass, lies a document that has sparked one of the most contentious debates in medieval scholarship. A Vinland map, a world chart, supposedly drawn around 1440, shows something that revolutionizes our understanding of pre-Columbian exploration. A clear depiction of North America, complete with a Norse inscription describing the voyages of Leif Erikson to lands he called Vinland. If authentic, the map represents the earliest known cartographic evidence that Europeans reached the New World, predating Columbus by half a century and providing documentary support for the Norse sagas that describe Viking expeditions to North America around 1000 CE. The map first surfaced in 1957 when it was acquired by Yale University from a European dealer in rare manuscripts. Bound together with two other medieval texts, the Historia Tartarorum and Vincent of Beauvais' Speculum Historiale, the Vinland map appeared to be part of a coherent medieval manuscript collection. The parchment, ink, and binding techniques all seemed consistent with 15th century European book production. Most remarkably, the map showed not only Europe, Asia, and Africa in configurations typical of medieval cartography, but also included an island in the Western Atlantic labeled Vinland Insula, accompanied by a Latin inscription describing how Bodne and Leif Erikson companions discovered a new land most fertile and even having vines. The geographical accuracy of the map's New World depiction astounded researchers. The landmass labeled as Vinland bears a striking resemblance to eastern North America, showing what appears to be Hudson Bay, the Great Lakes region, and the Atlantic coastline from Labrador to New England. The proportions and coastal configuration match modern geographical knowledge with accuracy that seems remarkable for any medieval mapmaker, whether working from Norse sources or pure speculation. Most significantly, the map shows North America as clearly separate from Asia, contradicting the geographical assumptions that influenced Columbus and other Renaissance explorers who expected to reach Asian territories by sailing west. Yet almost from the moment of its discovery, the Vinland map attracted skeptical scrutiny. Medieval scholars questioned whether any 15th century European cartographer possessed sufficient geographical knowledge to create such an accurate depiction of North American coastlines. The map's style and execution, while superficially consistent with medieval cartography, contained subtle anachronisms that suggested possible later origin. Most troubling of all, the map appeared to exist in isolation. No other medieval sources contained similar geographical information or supported the specific historical claims made in its inscriptions. Scientific analysis of the map began in the 1960s, using techniques available at that time to examine parchment, ink, and binding materials. Initial tests suggested authenticity. The parchment appeared to be genuine medieval vellum. Radiocarbon dating placed its origin in the appropriate time period, and the ink seemed consistent with medieval writing materials. These findings supported Yale's decision to publish the map in 1965 with scholarly commentary that endorsed its authenticity and proclaimed it as evidence of pre-Columbian European knowledge of America. However, more sophisticated analytical techniques developed in the 1970s began to reveal troubling inconsistencies. Microscopic examination of the ink disclosed the presence of anatase, a crystalline form of titanium dioxide that wasn't developed for use in inks until the 20th century. This discovery appeared to provide definitive proof that the map was a modern forgery, created using materials that weren't available to medieval scribes. The revelation severely damaged the map's credibility and led most scholars to dismiss it as an elaborate hoax. Yet the story didn't end with the anatase discovery. Subsequent research revealed that titanium dioxide can occur naturally in some medieval ink formulations, particularly those derived from certain mineral sources. The presence of anatase alone might not constitute proof of modern origin, especially if the quantity fell within ranges that could occur through natural processes, rather than deliberate addition of modern materials. This realization reopened the authenticity question and led to additional rounds of increasingly sophisticated analysis. The Vinland map controversy intensified as researchers applied new analytical techniques that yielded contradictory results. Some studies supported medieval origin, while others suggested modern creation. Carbon dating of the parchment consistently indicated genuine medieval material, but questions remained about when the actual map was drawn on that parchment. Spectroscopic analysis of the ink revealed complex chemical compositions that could be interpreted as either supporting medieval or modern origin, depending upon the analytical techniques employed and the assumptions made about medieval ink-making processes. The historical context of Norse exploration provides both support and challenges for the map's authenticity. Archaeological evidence from Lanzo Meadows in Newfoundland confirms that Vikings established settlements in North America around 1000 CE, exactly the time period described in the map's inscriptions. The Norse sagas contain detailed accounts of voyages to Vinland that match geographical features shown on the map. These historical sources provide plausible context for the geographical knowledge that the map claims to preserve. However, the transmission of such knowledge from 11th century Norse explorers to 5th-10th century European mapmakers presents significant historical problems. No other medieval sources contain similar geographical information about North America. The gap of 4 centuries between the supposed Viking voyages and the map's creation leaves ample time for geographical knowledge to be lost, distorted, or fabricated. Most significantly, if Europeans possessed accurate maps of North America in 1440, it becomes difficult to explain why Columbus and other later explorers showed no awareness of such knowledge. Recent technological developments have enabled even more sophisticated analysis of the Vinland map, but these advanced techniques have produced results that continue to contradict each other. Some studies using new spectroscopic methods have found evidence supporting medieval ink compositions, while others have detected additional anachronistic materials that suggest modern creation. The radiocarbon dating of parchment remains consistent with medieval origin, but questions persist about whether later ink additions could account for the geographical information shown on the map. The controversy has been further complicated by the discovery of additional documents that may relate to the Vinland map as origins. Researchers have identified other maps and manuscripts that contain similar geographical information or historical claims about pre-Columbian European exploration of America. Some of these documents appear to be genuine medieval works, while others show clear evidence of modern creation. The existence of both authentic and forged materials with similar content makes it increasingly difficult to determine which category includes the Vinland map itself. The debate has evolved beyond simple questions of authenticity to encompass broader issues about historical methodology and the evaluation of controversial evidence. Some scholars argue that the burden of proof should rest with those claiming medieval origin, given the extraordinary nature of the map's geographical knowledge and the potential for modern forgery. Others contend that the accumulating evidence of genuine medieval materials and historical context supports authenticity despite the presence of some anomalous analytical results. The Vinland map controversy illustrates the complex challenges involved in evaluating historical evidence that challenges established narratives. Whether the map represents genuine medieval preservation of Norse geographical knowledge, an elaborate modern forgery, or some combination of authentic materials with later additions, it continues to highlight the possibility that European knowledge of America may extend much further into the past than conventional historical accounts acknowledge. In its persistent ambiguity and contradictory evidence, the map serves as a reminder that the boundaries between historical fact and historical reconstruction may be far more uncertain than our confident textbook accounts suggest. In the vast blue expanse of the Pacific Ocean, where modern navigators rely on GPS satellites and sophisticated instruments to maintain their bearings across thousands of miles of empty water, the descendants of ancient Polynesian voyagers still practice navigation techniques that seem to transcend the physical limitations of human senses. They read wave patterns invisible to untrained eyes, interpret the flight paths of seabirds as precise navigational indicators, and maintain mental maps of island chains scattered across an ocean larger than all the world's landmasses combined. These are the last practitioners of a maritime tradition that, at its height, enabled human civilization to spread across the Pacific with accuracy and efficiency that modern sailors struggle to comprehend. The scale of Polynesian achievement in Pacific exploration staggers the imagination. From their original homeland, probably in the vicinity of modern Taiwan, Austronesian peoples gradually spread eastward across the Pacific over a period spanning thousands of years. By 1000 CE, they had reached virtually every habitable island, from Easter Island in the east to New Zealand in the south, establishing thriving civilizations on specks of land separated by ocean distances that exceed the width of entire continents. This expansion required navigational capabilities that enabled deliberate voyaging rather than accidental discovery, the ability to sail purposefully toward unseen destinations and return reliably to home ports across distances that would challenge modern mariners. The traditional explanation for Polynesian expansion emphasizes gradual island hopping over many generations, with each successful voyage enabling discovery of nearby islands that could serve as stepping stones for further exploration. This model suggests that Polynesian navigators gradually accumulated geographical knowledge through systematic exploration, building up mental maps of island chains and ocean regions through centuries of accumulated voyaging experience. While such gradual expansion certainly occurred, recent archaeological and linguistic evidence suggests that some Polynesian voyages covered much greater distances than island-hopping models would predict. The settlement of Easter Island presents perhaps the most striking example of long-distance Polynesian voyaging capability. Located over 2,000 miles from the nearest Polynesian centers, Easter Island represents one of the most isolated habitable locations on Earth. Yet archaeological evidence confirms that Polynesian settlers reached the island by 1200 CE, establishing a thriving civilization that created the famous Moai statues and developed unique cultural traditions. A voyage to Easter Island required deliberate navigation across vast stretches of empty ocean, suggesting navigational capabilities that enabled oceanic voyaging on a scale comparable to modern maritime exploration. The navigational techniques that enabled such extraordinary voyaging achievements depend upon systematic observation and interpretation of natural phenomena that most modern people never notice. Polynesian navigators learned to read subtle wave patterns that indicate the presence of distant islands through the interference effects of swells reflected from unseen land. They interpreted cloud formations that reveal islands beyond the horizon through the distinctive patterns of atmospheric moisture and thermal effects caused by land masses. They followed seasonal migrations of seabirds, whose flight paths connect feeding areas with nesting sites on distant islands. Most remarkably, Polynesian navigators developed techniques for maintaining accurate directional orientation during voyages lasting weeks or months without sight of land. They learned to interpret the positions and movements of stars with precision that enabled dead reckoning across thousands of miles of ocean. They developed understanding of seasonal wind patterns, current systems, and weather cycles that allowed them to predict and utilize favorable conditions for long-distance voyaging. They created mental maps of extraordinary complexity that integrated astronomical, meteorological, and oceanographic information into navigational systems of remarkable accuracy. The accuracy of traditional Polynesian navigation has been demonstrated repeatedly by modern experiments in which traditional navigators have successfully guided voyaging canoes across thousands of miles of Pacific Ocean using only indigenous techniques. Nanoa Thompson, trained by traditional Carolinian navigator Mo Pialug, has completed numerous long-distance voyages using traditional wayfinding methods, including successful journeys from Hawaii to Tahiti and beyond. These modern demonstrations confirm that traditional Polynesian navigation techniques are capable of achieving the precision and reliability necessary for deliberate trans-Pacific exploration. Yet the full scope of Polynesian geographical knowledge may extend far beyond what conventional archaeological evidence has documented. Traditional Polynesian chants and oral histories contain references to lands and voyaging routes that seem to describe geographical features outside the conventionally understood boundaries of Polynesian exploration. Some traditions describe voyages to continental landmasses that could represent contacts with the Americas, Australia, or even Asia. While such accounts are often dismissed as mythological rather than historical, they might preserve memories of actual voyaging achievements that extended Polynesian exploration much further than archaeological evidence currently supports. The possibility of Polynesian contact with the Americas has gained support from biological and archaeological evidence that suggests pre-Columbian trans-Pacific exchange. Sweet potatoes, a South American crop, appear in Polynesian agriculture before any known European contact that could have introduced them. Chickens, apparently of Polynesian origin, have been found in pre-Columbian archaeological sites in Chile. While such evidence remains controversial and subject to alternative explanations, it suggests that Polynesian voyaging capabilities may have enabled contacts with distant continents that conventional Pacific history has overlooked. Ancient maps from various sources occasionally show Pacific islands and island chains in positions and configurations that suggest access to Polynesian geographical knowledge. Chinese maps from medieval periods sometimes depict Pacific island systems with accuracy that seems to exceed what Chinese maritime exploration could have achieved independently. European maps from the early colonial period occasionally show Pacific geographical features that were not officially discovered until much later exploration, suggesting that European cartographers may have had access to indigenous Pacific geographical knowledge through early contact with Polynesian navigators. The integration of Polynesian navigation with astronomical observation created knowledge systems that combined terrestrial and celestial information in ways that enabled extraordinary geographical achievements. Polynesian star maps preserved in oral tradition show understanding of stellar positions and movements with accuracy that supported precise navigation across vast ocean distances. The same astronomical knowledge that enabled such accurate wayfinding could have supported systematic mapping of Pacific geography on a scale that conventional understanding of Polynesian capabilities has underestimated. Traditional Polynesian navigation techniques also incorporated what modern science might classify as intuitive or psychic elements, alongside systematic observation of natural phenomena. Experienced navigators reported abilities to sense the presence of distant land through subtle changes in ocean conditions, atmospheric pressure, or other environmental factors that couldn't be measured by available instruments. Some navigators claimed to receive guidance through dreams, visions, or communication with ancestral spirits who possessed superior geographical knowledge. While such reports are difficult to evaluate using conventional scientific methods, they suggest that Polynesian navigation may have incorporated consciousness-based information-gathering techniques alongside systematic observation. The decline of traditional Pacific navigation following European colonization led to the loss of geographical knowledge that may have encompassed far more of the Pacific than archaeological evidence currently indicates. Many island populations were disrupted or eliminated by disease, warfare, and cultural suppression before their navigational knowledge could be systematically documented. Traditional chants, oral maps, and navigational techniques vanished with the cultures that created and maintained them, leaving only fragmentary traces of what may have been one of humanity's most sophisticated geographical knowledge systems. Whether traditional Polynesian navigation enabled exploration and mapping on a scale that conventional Pacific history has underestimated, incorporated consciousness-based techniques that conventional science cannot explain, or preserved geographical knowledge obtained through entirely unknown means, it represents one of humanity's most remarkable achievements in maritime exploration and navigation. The techniques that enabled Polynesian expansion across the Pacific demonstrate human capabilities for geographical exploration and knowledge acquisition that continue to challenge our understanding of what pre-technological civilizations could achieve through systematic observation, accumulated experience, and innovative adaptation to natural environmental conditions. In the libraries of Beijing, among collections of ancient scrolls that span millennia of Chinese civilization, lies cartographic evidence of geographical knowledge that challenges conventional understanding of both Chinese maritime capabilities and the scope of ancient global exploration. Chinese maps dating from the medieval period occasionally display features that seem to exceed what official Chinese exploration achieved, showing lands and coastlines that wouldn't be documented by Chinese voyagers until much later periods, if ever. Most intriguingly, some Chinese charts appear to show configurations resembling the Americas, depicted with detail that suggests systematic surveying rather than speculative cartography. The most famous example of impossible Chinese geographical knowledge appears in the work of Admiral Zheng He, whose massive treasure fleets conducted 7 major expeditions between 1405 and 1433. These voyages, involving hundreds of ships and tens of thousands of personnel, officially reached Southeast Asia, India, Persia, Arabia, and the eastern coast of Africa. The scale and sophistication of Zheng He's expeditions dwarfed contemporary European exploration, demonstrating Chinese maritime capabilities that wouldn't be matched by any other civilization for centuries. Yet maps associated with Zheng He's voyages sometimes show geographical knowledge that seems to extend far beyond the documented routes of his treasure fleets. The Ji Beizi, a Chinese military manual from 1621 that incorporates much earlier cartographic sources, contains world maps that show what appear to be the Americas in recognizable configuration. These depictions include coastlines that bear striking resemblance to the eastern seaboard of North America and the western coast of South America. complete with geographical features that match modern knowledge of American geography. The maps show these American landmasses connected to Asian territories, suggesting either advanced understanding of Beringian land bridges or systematic exploration of Pacific territories that official Chinese records do and document. The accuracy of details in these Chinese maps of supposed American territories exceeds what speculation or indirect knowledge could plausibly achieve. Coastal indentations, river systems, and proportional relationships between different geographical regions match modern surveys with precision that systematic exploration seems required to explain. Most remarkably, some Chinese maps show the Americas in correct longitudinal relationship to Asian territories, demonstrating understanding of global geography that accurate longitude measurement would be necessary to achieve. Chinese historical records contain tantalizing references to voyages and territories that extend far beyond the conventionally understood scope of Chinese exploration. The Shanhai Jing, an ancient Chinese text describing mythical lands and peoples, contains geographical descriptions that some researchers interpret as referring to American territories and peoples. While mainstream sinology treats these accounts as mythological rather than historical, the geographical details sometimes match actual American features with accuracy that seems to exceed what pure imagination could achieve. A possibility of Chinese trans-Pacific contact gains support from archaeological evidence that suggests pre-Columbian Asian influence in the Americas. Artifacts found in various American archaeological sites show design motifs, construction techniques, and material compositions that resemble Chinese and other Asian cultural traditions. DNA studies of some Native American populations reveal genetic markers that suggest Asian contact more recent than the original migration across the Bering Land Bridge. While such evidence remains controversial and subject to alternative interpretations, it provides potential support for the geographical knowledge displayed in Chinese maps. Buddhist texts and traditions preserved in Chinese sources occasionally contain references to lands across the Eastern Ocean that could represent knowledge of American territories. The legendary journey of Hui Shen, a Buddhist monk who supposedly traveled to a land called Fusang in the 5th century CE, describes geographical and cultural features that some researchers interpret as referring to Mexico or other parts of the Americas. While conventional scholarship treats the Fusang account as mythological, the specific details of geography, flora, fauna, and human culture sometimes match American conditions with remarkable accuracy. Chinese astronomical records demonstrate mathematical and observational capabilities that could have supported trans-Pacific navigation and geographical surveying. Ancient Chinese astronomers developed sophisticated understanding of stellar positions, planetary cycles, and calendar systems that enabled precise timekeeping and directional orientation. The same mathematical astronomy that supported accurate Chinese calendars and agricultural planning could have provided the technological foundation for oceanic navigation and systematic geographical surveying on a global scale. The naval technology available to Chinese civilization during the medieval period far exceeded what any other contemporary culture possessed. Chinese ships of the treasure fleet era reached lengths exceeding 400 feet, incorporated multiple masts with sophisticated rigging systems, and employed navigation techniques that included magnetic compasses, detailed charts, and systematic astronomical observation. Such vessels possessed the size, seaworthiness, and navigational equipment necessary for trans-Pacific voyaging, suggesting that Chinese maritime capabilities were adequate for exploration far beyond the documented routes of official expeditions. The political and economic motivations that drove Chinese exploration during the treasure fleet period could have supported much more extensive geographical exploration than official records document. The Ming Dynasty sought to establish Chinese influence and extract tribute from territories throughout the known world. Discovering and establishing contact with previously unknown lands would have served obvious political and economic purposes. providing new sources of exotic goods, strategic territories, and diplomatic influence. The scale of resources devoted to Zheng He's expeditions demonstrates Chinese willingness to invest enormous effort in maritime exploration. The abrupt termination of Chinese treasure fleet expeditions in 1433 led to official suppression of maritime exploration and destruction of many navigation records and geographical documents. This policy shift, motivated by changing political priorities and economic constraints, resulted in the deliberate elimination of much Chinese geographical knowledge and maritime capability. Maps, charts, and exploration records were destroyed or forgotten, leaving only fragmentary evidence of what may have been much more extensive Chinese geographical knowledge and exploration achievement. The secrecy that surrounded Chinese imperial activities during various dynastic periods may have concealed geographical discoveries that were never made public or recorded in surviving documents. Chinese expeditions conducted for military, diplomatic, or commercial purposes often operated under strict secrecy requirements that prevented public documentation of routes, discoveries, or territorial claims. Such secret expeditions could have achieved geographical exploration far beyond what surviving records indicate, leaving only occasional cartographic traces of much more extensive Chinese global knowledge. Traditional Chinese geographical concepts incorporated territories and regions that don't correspond to modern understanding of global geography, but which may preserve memories of actual lands that Chinese explorers discovered and mapped. Chinese cosmological texts describe various world systems, multiple continents, and geographical relationships that conventional scholarship treats as mythological, but which might represent systematic geographical knowledge encoded in traditional symbolic frameworks. Whether Chinese maps that appear to show the Americas preserve evidence of actual trans-Pacific exploration, represent knowledge acquired through alternative means, or document geographical information obtained from entirely unknown sources, they demonstrate that Chinese geographical understanding may have encompassed far more of the global surface than conventional sinological and historical scholarship has recognized. The precision and systematic nature of geographical knowledge displayed in Chinese cartographic sources suggests capabilities for global exploration and surveying that would require fundamental revision of our understanding of both Chinese maritime achievement and the scope of ancient geographical knowledge. For over 2 millennia, European scholars and cartographers operated under a compelling geographical assumption that would shape exploration, influence imperial ambitions, and ultimately lead to one of history's most persistent cartographic myths. Terra Australis Incognita, the unknown southern land, appeared on European maps from classical antiquity through the 18th century, depicted as a vast continent that balanced the landmasses of the northern hemisphere and provided geographical symmetry essential to maintaining the Earth's stability. This theoretical continent grew larger and more detailed with each generation of mapmakers, acquiring coastlines, mountain ranges, river systems, and even hypothetical cities, despite the fact that no European explorer had ever set foot upon its shores or confirmed its existence through direct observation. The concept originated in classical Greek geography, where philosophers like Aristotle and mathematicians like Ptolemy theorized about the Earth as structure and the distribution of land and water across its surface. Greek geographical theory demanded balance between northern and southern landmasses to prevent the Earth from becoming unstable in its celestial rotation. The known continents of Europe, Asia, and northern Africa required corresponding southern territories to maintain this essential equilibrium. Ptolemy's influential Geographia incorporated Terra Australis as a necessary geographical feature, setting the theoretical foundation for over 1,000 years of European cartographic tradition. Medieval European mapmakers inherited Ptolemy's geographical framework and elaborated upon it with increasing specificity and detail. The Terra Australis of medieval maps grew from a simple theoretical landmass into an elaborate continental system complete with coastal features, inland territories, and connections to other known lands. The Hereford Mappa Mundi, created around 1300, shows southern lands that extend far beyond what any contemporary exploration could have documented. These depictions suggest that medieval cartographers were drawing upon sources beyond mere classical theory, incorporating geographical information that seemed to exceed the boundaries of speculative cartography. Renaissance mapmakers transformed Terra Australis from theoretical necessity into cartographic certainty, depicting the southern continent with confidence that suggested definitive knowledge rather than educated speculation. Maps by Abraham Ortelius, Gerard Mercator, and other 16th century masters show Terra Australis as an established geographical feature, complete with Latin place names, detailed coastlines, and proportional relationships to other continents. These depictions influenced European exploration strategies for centuries, as navigators sought passages to the southern continent, and colonial powers planned territorial claims in lands that existed primarily in cartographic imagination. The persistence and consistency of Terra Australis depictions across different mapmakers and time periods suggests that European cartographers were working from common sources rather than developing independent speculative geographies. The continent consistently appeared in similar positions relative to other landmasses, maintained comparable proportions across different map projections, and showed geographical features that remained stable across multiple cartographic traditions. Such consistency implies that Terra Australis represented more than pure speculation, perhaps preserving geographical knowledge derived from sources that conventional European exploration hadn't yet confirmed. As European exploration expanded during the Age of Discovery, the hypothetical geography of Terra Australis began to conflict with actual geographical discoveries. Portuguese and Spanish navigators exploring the southern oceans failed to encounter the vast continent that maps confidently depicted. Instead, they found isolated islands, open ocean, and weather conditions that made systematic exploration of southern waters extremely difficult. These discoveries gradually reduced the probable size and extent of Terra Australis, but didn't eliminate the continent entirely from European geographical thinking. The Dutch exploration of Australian and New Zealand territories in the 17th century provided the first definitive evidence of substantial southern landmasses, but these discoveries created as many geographical puzzles as they resolved. The lands that Dutch navigators discovered were clearly significant, but they didn't match the configuration or extent of the Terra Australis that European maps had depicted for centuries. Australia appeared to be separated from other southern territories by vast ocean distances, rather than connected as part of a unified southern continental system. New Zealand consisted of isolated islands rather than peninsular extensions of a larger continent. James Cook's systematic exploration of the southern Pacific in the 18th century finally provided definitive answers about Terra Australis, but those answers challenged fundamental assumptions about the relationship between theoretical geography and actual exploration. Cook's voyages demonstrated conclusively that no vast southern continent existed in the positions where European maps had confidently placed it for over a millennium. The Terra Australis that had influenced European geographical thinking since classical antiquity proved to be largely mythical, existing in cartographic tradition rather than physical reality. Yet Cook's exploration also revealed that substantial southern landmasses did exist, but in configurations and positions that differed dramatically from traditional European expectations. Antarctica, discovered during subsequent 19th century expeditions, provided the southern continental landmass that geographical theory demanded, but it was ice-covered, uninhabitable, and located much further south than traditional Terra Australis depictions had suggested. Australia proved to be a significant continent, but isolated and positioned differently than Terra Australis theories had predicted. The most intriguing aspect of the Terra Australis myth lies not in its eventual disproof, but in the accuracy of certain details that European cartographers somehow incorporated into their depictions of the theoretical continent. Some features of traditional Terra Australis maps correspond remarkably well with actual southern geography when adjusted for the different positions and configurations that exploration eventually revealed. Coastal patterns, proportional relationships, and geographical connections shown in speculative maps sometimes match actual southern hemisphere geography with precision that pure speculation seems unlikely to achieve. The possibility that Terra Australis depictions preserved fragments of accurate geographical knowledge encoded within theoretical frameworks gained support from the sophisticated mathematical and astronomical knowledge that European cartographers possessed during the medieval and Renaissance periods. The same computational abilities that enabled accurate calendar systems, navigation techniques, and architectural achievements could have supported geographical knowledge acquisition through methods that did and depend upon direct physical exploration. Some researchers propose that Terra Australis maps preserved geographical information transmitted through ancient sources that European scholars could access, but not fully understand or verify. Classical texts occasionally contained references to southern lands and peoples that could represent preserved memories of actual exploration achievements by civilizations whose maritime capabilities conventional history has underestimated. Medieval contacts with Islamic geographical scholarship provided European cartographers with access to ancient knowledge that might have included accurate information about southern territories encoded within theoretical geographical frameworks. The integration of astronomical observation with geographical theory during the Renaissance created possibilities for acquiring accurate geographical information through mathematical calculation and systematic observation rather than direct physical exploration. European scholars who possessed sophisticated understanding of the Earth's dimensions, celestial mechanics, and global coordinate systems might have been able to deduce the existence and approximate positions of southern landmasses through purely theoretical methods that proved remarkably accurate. Alternative theories suggest that Terra Australis depictions preserved geographical knowledge acquired through consciousness-based exploration techniques that did not require physical travel to distant territories. Many traditional cultures report geographical knowledge obtained through shamanic journeys, visionary experiences, and other altered states of consciousness that provide direct access to information about remote locations. If such techniques were available to European scholars and cartographers, they could account for the accuracy of certain Terra Australis features without invoking conventional exploration or ancient source materials. Whether the Terra Australis myth preserved fragments of genuine geographical knowledge, represented sophisticated theoretical geography that accidentally approximated actual conditions, or documented information acquired through entirely unknown methods, it demonstrates that the relationship between cartographic tradition and physical exploration is far more complex than simple mapping of discovered territories. The myth illustrates how theoretical geography can influence actual exploration, how speculative cartography can preserve accurate information within apparently fictional frameworks, and how the boundaries between imagination and knowledge may be less distinct than conventional understanding suggests. In its persistent influence on European exploration and its occasional accuracy despite theoretical origins, Terra Australis continues to challenge assumptions about how geographical knowledge develops, circulates, and persists across centuries of human civilization. Brother Thomas paused at the threshold of the scriptorium's innermost chamber, his hand trembling slightly as he gripped the heavy iron key. The autumn of 1347 had brought more than the usual chill to the Abbey of St. Denis. It had brought whispers of plague from the eastern lands, and more disturbing to the scholarly monks stories of ancient documents being discovered in the ruins of Constantinople's libraries. For 3 months, the sealed chest had waited in this forgotten corner of the monastery's archives, its contents known only to the abbot and 2 senior brothers, who spoke of it in hushed Latin phrases that conveyed both reverence and unease. The chamber itself seemed to hold its breath as Thomas entered. Dust motes danced in the narrow shaft of light that penetrated through the single window, illuminating walls lined with manuscripts that chronicled centuries of accumulated knowledge. Some texts dated to the monastery's founding in the 7th century, while others contained Greek and Arabic works, translated by scholarly communities that maintained learning through Europe's darkest periods. But the chest that dominated the chamber's center was different, older, bearing symbols that none of the brothers could definitively identify, crafted from wood that seemed almost black with age. As Thomas lifted the lid, the scent of ancient parchment mingled with something else, a faint aroma that reminded him of sea voyages he had never taken, of distances that stretched beyond the monastery's familiar borders. Inside, wrapped in silk that had once been purple but had faded to the color of twilight, lay a single large document. The map unrolled slowly, reluctantly, as if it had grown comfortable with centuries of concealment and resisted returning to human observation. What Thomas saw challenged everything he understood about the world's geography. The familiar outlines of Europe and Africa appeared recognizable enough, rendered in the careful detail that characterized the finest medieval cartography. But beyond these known territories, the map showed lands that no Christian kingdom claimed, no monastery chronicled, no pilgrim had ever described in the travelers' accounts that occasionally reached their remote abbey. Vast continents stretched across regions where Brother Thomas had been taught only ocean existed, marked with symbols and annotations in scripts that seemed to shift between Latin, Greek, and characters he couldn't identify. The southern regions of the map particularly disturbed his understanding of divine geography, where learned treatises placed the theoretical lands that balanced God's creation. This ancient chart showed specific coastlines, mountain ranges, and river systems drawn with the precision of a surveyor's direct observation. More troubling still, the map depicted these southern territories as temperate and habitable, covered with symbols that seemed to indicate cities, harbors, and cultivated lands. Such depictions contradicted the theological understanding that placed paradise in the east and relegated the southern regions to the realm of monsters and divine mystery. But it was the western portions of the map that truly shook Brother Thomas's faith in established knowledge. Beyond the ocean sea, where all learned authorities placed only water stretching to the world's edge, the ancient document showed vast landmasses that dwarf even the known continents of Europe and Africa. These western lands appeared to be inhabited and civilized, marked with the same symbols of human settlement that the mapmaker had used to denote the great cities of the Mediterranean world. The implications staggered Thomas. If such lands truly existed, they contained Christian souls who had never heard the gospel, civilizations that existed beyond the reach of papal authority. The mathematical precision of the map's construction became apparent as Thomas studied its details more closely. The coastlines weren't drawn with the artistic approximation typical of medieval cartography, but with geometrical accuracy that suggested systematic surveying and measurement. Latitude lines appeared at regular intervals, marked with numbers that employed a mathematical system Thomas recognized from the Arabic texts in the monastery's collection. Most remarkably, the map included longitude markings that enabled precise positioning of geographical features across the entire world, surface a capability that European scholarship would not achieve for centuries to come. Notations scattered across the map's surface provided additional mysteries. Some appeared to be written in Latin, but employing words and phrases that Thomas couldn't locate in any text the monastery possessed. Others used Greek characters arranged in combinations that didn't match classical Greek or the Byzantine Greek that occasionally appeared in Eastern manuscripts. Most puzzling of all were inscriptions that seemed to employ familiar letters in unfamiliar arrangements, as if the mapmaker had developed alternative languages or encoding systems that preserved geographical knowledge in forms that couldn't be easily deciphered by casual observers. The implications of the map's existence troubled Brother Thomas more than its geographical impossibilities. If ancient peoples had possessed such comprehensive knowledge of the world's lands and seas, why had this knowledge been lost to Christian civilization? The map suggested capabilities for global exploration and systematic surveying that exceeded anything achieved by contemporary kingdoms or trading empires. It implied the existence of civilizations whose technological and organizational achievements had somehow vanished from historical record, leaving only this single cartographic witness to their extraordinary accomplishments. As evening approached and the chamber's light began to fade, Thomas carefully rewrapped the map in its silk covering and secured it once again within the ancient chest. But the images remained burned in his memory: coastlines that shouldn't exist, continents that defied theological geography, and mathematical precision that challenged fundamental assumptions about human capabilities and divine creation. The map represented more than geographical knowledge. It suggested possibilities about the world's true extent and humanity as hidden history that threatened to overwhelm the comfortable certainties of monastic scholarship. Brother Thomas never spoke openly about what he had seen in the monastery's secret chamber. The map remained locked away, known only to a few senior members of the community who maintained their silence through a combination of scholarly discretion and theological uncertainty. When the Black Death reached the Abbey of St. Denis in the spring of 1348, it claimed Brother Thomas, along with half the monastery's population. The knowledge of the map's existence died with him, leaving the ancient document to wait in its sealed chamber for future generations who might possess the courage and capability to confront its impossible revelations. The Abbey of St. Denis itself survived the plague, the 100 Years' War, and the religious upheavals that swept medieval Europe. But the secret chamber gradually receded into institutional memory as successive generations of monks focused on more immediate concerns of survival, scholarship, and spiritual development. The map remained patient and persistent in its dark corner, preserving knowledge that challenged the boundaries of geographical possibility, while waiting for an age that might possess the tools and wisdom necessary to understand its extraordinary claims about the true extent of the world and the lost achievements of ancient human civilization. Deep beneath the Antarctic ice sheet, in cores of ancient ice extracted by patient scientific drilling, lie layers that tell a story far more complex than simple continental freeze. As researchers analyze these frozen archives of planetary history, they discover periods when Antarctica's climate differed dramatically from its current frozen state. Pollen grains from temperate forests appear in geological strata. Marine organisms that require warmer waters have left fossil evidence in areas now locked beneath miles of permanent ice. Most remarkably, recent paleoclimatic research suggests that portions of Antarctica may have experienced ice-free conditions much more recently than conventional geological models predicted, perhaps within the range of human historical memory. The emerging science of paleogeography, the study of ancient geographical configurations, provides context for understanding how dramatically the Earth's surface can change over relatively short geological periods. Continental positions, ocean levels, and climate patterns have fluctuated throughout planetary history in ways that create geographical conditions completely different from those we observe today. During the last ice age, sea levels dropped over 120 meters below current levels, exposing vast continental shelves that are now submerged. Land bridges connected continents that are now separated by hundreds of miles of ocean. Climate patterns supported vegetation and animal life in regions that are now uninhabitable deserts or frozen wastelands. The most significant paleographical discoveries relate to the dynamic nature of continental ice coverage, rather than being static features that remain constant for millions of years. Continental ice sheets expand and contract in response to complex interactions between solar radiation, atmospheric composition, ocean currents, and geological processes. The West Antarctic ice sheet, in particular, appears to be much less stable than previously believed, with geological evidence suggesting multiple episodes of collapse and reformation over relatively recent time periods. Recent research into Antarctic paleoclimatology has revealed that the continent's ice coverage has varied dramatically, even within the time frame of human civilization. Ice core analysis indicates warming periods when significant portions of Antarctica supported liquid water systems, vegetation growth, and potentially habitable conditions. Some studies suggest that coastal regions of Antarctica remained ice-free as recently as 6,000 years ago. Well, within the period when advanced human civilizations were developing sophisticated technologies, including potentially global navigation capabilities. The implications for understanding ancient maps become profound when considered alongside this paleoclimatic evidence. If portions of Antarctica were indeed ice-free during recent millennia, then human civilizations with adequate maritime technology could have observed and mapped these regions during habitable periods. The accurate depictions of Antarctic coastlines and geographical features in ancient maps might preserve direct, observational knowledge rather than impossible speculation or supernatural revelation. Submarine geology provides additional support for recent Antarctic ice-free periods. Seafloor surveys around Antarctica reveal extensive areas of continental shelf that were clearly exposed to subaerial erosion weathering patterns that occur only when land surfaces are above sea level and experiencing normal atmospheric conditions. The timing of this erosion appears much more recent than conventional models of continuous Antarctic glaciation would predict. Some geological evidence suggests that extensive land areas around Antarctica were exposed and potentially habitable within the last 10,000 years. The concept of rapid climate change, now well established through studies of ice age transitions, provides mechanisms by which Antarctica could shift between habitable and uninhabitable states within relatively short time periods. Paleoclimatic research has demonstrated that global climate systems can undergo dramatic transitions within decades or centuries, rather than requiring millions of years for major changes. Such rapid transitions could move Antarctica between temperate and frozen states quickly enough that human civilizations might experience and record both conditions. Ocean circulation patterns provide crucial mechanisms for rapid Antarctic climate change. The Antarctic Circumpolar Current, which isolates Antarctica from warmer ocean waters, is dependent upon specific configurations of continental positions and ocean basin geometry. Changes in global ocean circulation caused by sea level fluctuations, continental movement, or atmospheric pattern shifts could dramatically alter Antarctic temperatures within relatively short time periods. During periods of altered circulation, warm ocean waters could reach Antarctic shores and prevent ice sheet formation over extensive coastal regions. Volcanic activity presents another mechanism for rapid Antarctic environmental change. Antarctica contains numerous active volcanic systems, some of which lie beneath current ice coverage. Major volcanic eruptions could generate sufficient heat to melt extensive ice areas and create temperate microclimates that could persist for centuries or millennia. Volcanic ash and carbon dioxide emissions could also alter atmospheric conditions in ways that promote regional warming and ice sheet retreat. The stability of the West Antarctic ice sheet has become a major focus of contemporary climate research, with findings that have startling implications for understanding ancient geography. Unlike the East Antarctic ice sheet, which rests on bedrock above sea level, much of the West Antarctic ice sheet sits on bedrock that lies below sea level. This configuration makes it potentially unstable if ocean warming causes ice shelf collapse. The entire West Antarctic system could disintegrate rapidly, exposing extensive land areas and dramatically altering global geography. Geological evidence suggests that West Antarctic ice sheet collapse has occurred multiple times in recent geological history, most recently during the last interglacial period, approximately 125,000 years ago. During these collapse episodes, much of West Antarctica would have been ice-free, supporting temperate climates and potentially habitable conditions. If similar collapses occurred during the period of human civilization development, they could provide the ice-free Antarctic conditions that ancient maps appear to document. Recent discoveries of preserved organic material beneath Antarctic ice have revealed ecosystems that survived much longer than conventional glaciation models predicted. Microorganisms, plant remains, and even complex organic structures have been found in geological layers that suggest ice-free conditions existed in various Antarctic regions during periods when the continent was supposedly completely frozen. These discoveries support the possibility that significant portions of Antarctica remained habitable during recent millennia. The relationship between Antarctic geography and global sea levels creates additional possibilities for recent ice-free conditions. During periods of reduced global ice volume, sea levels rise and ocean circulation patterns change in ways that could bring warm water to Antarctic shores. Conversely, during periods of extensive northern hemisphere glaciation, atmospheric and oceanic patterns could shift in ways that warm Antarctic regions, even while cooling other parts of the planet. Such complex interactions could create windows of Antarctic habitability that don't correspond to simple global temperature patterns. Astronomical cycles provide long-term drivers for Antarctic climate change that operate on timescales compatible with human historical development. Milankovitch cycles changes in Earth as orbital parameters that affect solar radiation distribution create periodic warming and cooling patterns that influence ice sheet stability over periods of thousands to tens of thousands of years. These cycles could have created recent episodes of Antarctic warming and ice retreat that coincided with the development of advanced ancient civilizations. Whether ancient maps preserve observational knowledge of ice-free Antarctica or document geographical information acquired through entirely different means, the emerging understanding of Antarctic paleoclimatology demonstrates that the continent's environmental history is far more dynamic and complex than simple models of continuous glaciation suggest. The science of paleogeography provides plausible natural mechanisms by which Antarctica could have been habitable and mappable during periods of human civilizational development, lending scientific credibility to the possibility that ancient cartographers possessed direct knowledge of geographical conditions that conventional history has deemed impossible. Beneath the familiar geography of continents and oceans, according to certain cartographic traditions that stretch across cultures and centuries, lies another world entirely. Not the molten core of geological textbooks, but vast hollow spaces containing their own continents, seas, and civilizations and inner Earth that ancient maps occasionally depicted with the same careful attention to detail that characterized their representations of surface geography. These charts of the world within the world represent perhaps the most extraordinary branch of impossible cartography, suggesting either purely fantastical speculation or knowledge of terrestrial dimensions that conventional science has never acknowledged. The concept of a hollow Earth appears in mythological and religious traditions worldwide, from the ancient Greek underworld to Norse descriptions of realms beneath the surface to Hindu cosmology that describes multiple levels of terrestrial existence. But certain historical maps go beyond mythological symbolism to present what appear to be systematic geographical surveys of subterranean territories. These charts show not the supernatural realms of religious imagination, but recognizable geographical features, coastlines, mountain ranges, river systems, and inhabited territories that exist in dimensions parallel to but separate from surface geography. Medieval European maps occasionally included depictions of underground territories that seemed to represent actual geographical knowledge rather than theological symbolism. The famous Hereford Mappa Mundi contains regions that appear to exist beneath or within the Earth's surface, marked with the same cartographic conventions used for surface territories. These subterranean areas include detailed coastlines, settlements, and transportation routes that suggest systematic exploration rather than speculative imagination. Most remarkably, Some medieval maps show connections between surface and underground geography passages, caves, and tunnels that provide access routes between the familiar world and hidden realms beneath. Renaissance cartographers continued this tradition of depicting inner Earth geography with increasing sophistication and detail. Maps by Athanasius Kircher and other 17th century scholars show elaborate underground systems complete with their own mountain ranges, ocean basins, and continental configurations. Kircher's Mundus Subterraneus, published in 1665, presents what purports to be systematic geographical knowledge of subterranean territories based on careful research and compilation of multiple sources. The level of detail and internal consistency in these maps suggests access to information that pure speculation would be unlikely to generate. The mathematical precision required to create accurate maps of inner Earth territories would exceed even the challenges of surface cartography. Subterranean navigation would require alternative methods of orientation and distance measurement that do and depend upon celestial observation or familiar landmarks. The mapping of underground territories would necessitate systematic exploration of cave systems, tunnel networks, and underground chambers on a scale that would dwarf any known archaeological excavation. Yet certain historical maps of inner Earth geography display the kind of systematic accuracy and detailed knowledge that such comprehensive exploration would produce. Indigenous traditions from various continents contain accounts of extensive underground territories that support their own geographical systems and civilizations. Native American traditions speak of tunnel systems that connect different regions of the continent, cave networks that extend for hundreds of miles, and underground territories that provide refuge during surface catastrophes. Similar traditions appear in South American indigenous accounts, Tibetan Buddhist texts, and Aboriginal Australian folklore. The consistency of these accounts across geographically and culturally separated peoples suggests possible common origins and actual knowledge of subterranean geography. Modern speleology, the scientific study of caves and underground systems, has revealed that extensive subterranean territories do exist in forms that approach the scope suggested by ancient maps of inner Earth geography. Mammoth Cave in Kentucky extends for over 400 mapped miles, making it the world's longest known cave system. The Son La Cave system in Vietnam contains passages large enough to accommodate entire forests and underground rivers. Newly discovered cave networks in various parts of the world continue to reveal underground territories of surprising extent and complexity. The discovery of vast underground ocean systems provides additional support for the possibility of extensive subterranean geography. Recent geological research has identified water reserves deep within the Earth's mantle that exceed the volume of all surface oceans combined. These underground water systems could potentially support the kind of extensive subterranean hydrological cycles that inner Earth maps seem to depict. Underground rivers, lakes, and even ocean-sized water bodies could exist in geological configurations that surface geography doesn't reveal. Archaeological discoveries of extensive ancient tunnel systems suggest that past civilizations possessed capabilities for underground construction and navigation that conventional history has underestimated. The Cappadocia underground cities in Turkey extend for multiple levels and could accommodate thousands of inhabitants. Similar underground complexes have been discovered in various parts of the world, often showing construction techniques and engineering sophistication that exceed what surface archaeological evidence might predict. These discoveries demonstrate that ancient peoples possessed both the technology and motivation for extensive subterranean development. The possibility of natural underground spaces large enough to support their own geographical systems gains credibility from recent discoveries in planetary science. Mars apparently contains underground caverns and tunnel systems of enormous extent. Similar subterranean spaces may exist on Earth, but remain undetected due to the limitations of surface-based geological survey techniques. Advanced Cave-forming processes could create underground territories of continental scale without necessarily leaving obvious surface indications of their existence. Geophysical anomalies detected through seismic surveys and gravitational measurements occasionally reveal large subsurface voids that could represent substantial underground spaces. Some of these anomalies appear too large and too systematically distributed to result from known geological processes, suggesting the possibility of subterranean territories that conventional geology has not yet explained. While most geophysical anomalies receive conventional explanations involving mineral deposits or structural geology, some remain puzzling enough to support speculation about more exotic underground geography. The relationship between underground geography and surface topography could create navigational systems that enable accurate mapping of subterranean territories. Cave systems often follow geological structures that correlate with surface features, creating underground topography that parallels surface geography in predictable ways. Experienced cave navigators could potentially develop systematic knowledge of underground territories by understanding these correlations between surface and subterranean geography. Traditional accounts of inner Earth exploration often describe access routes through polar regions, mountain caves, or oceanic depths that provide entry points to extensive underground territories. The Arctic and Antarctic regions in particular feature prominently in accounts of subterranean access, with explorers reporting discoveries of warm underground areas and entrances to vast cave systems. While such accounts are typically dismissed as fictional, they correspond with geographical features that could conceivably provide access to extensive underground territories. The biological requirements for supporting life in underground environments are less restrictive than surface conditions might suggest. Many cave ecosystems support complex biological communities that have adapted to subterranean conditions. Geothermal energy sources could provide heating and power for underground civilizations. Underground water systems could support agriculture and transportation. The absence of solar radiation, while eliminating photosynthesis-based ecosystems, wouldn't necessarily prevent the development of alternative biological systems based on geothermal or chemical energy sources. Whether maps depicting inner Earth geography preserve knowledge of actual subterranean territories, represent symbolic encoding of geological or spiritual concepts, or document something entirely beyond conventional understanding, they demonstrate human awareness of terrestrial dimensions that extend beyond familiar surface geography. The consistency and detail of these cartographic traditions across different cultures and time periods suggest that the relationship between human knowledge and planetary geography may encompass territories and dimensions that conventional Earth science has yet to fully investigate or acknowledge. In their precise depictions of impossible territories, inner Earth maps continue to challenge assumptions about the completeness of geographical knowledge and the true extent of terrestrial space available for exploration and habitation. In the pre-dawn darkness of the Pacific Ocean, a Carolinian navigator sits motionless in the bow of his outrigger canoe, feeling vibrations through the hull that reveal the presence of an island still invisible beyond the horizon. His training has taught him to read wave patterns that European sailors cannot even perceive, subtle interference patterns where swells from distant lands create standing wave formations that persist for hundreds of miles across open ocean. This navigator possesses no instruments beyond his own senses, yet he can guide his vessel across thousands of miles of apparently empty sea with accuracy that GPS systems struggle to match. His knowledge represents the living remnant of navigation technologies that once enabled human civilization to explore and map the entire planet with precision that modern science is only beginning to understand. The sophistication of traditional Polynesian navigation suggests that ancient peoples possessed technological capabilities far exceeding what conventional archaeology attributes to pre-industrial civilizations. The techniques required for accurate long-distance oceanic navigation demand mathematical understanding of celestial mechanics, systematic knowledge of meteorological patterns, and precise awareness of geographical relationships that would seem to require instrumental observation and computational abilities. Yet traditional navigators achieve this accuracy using mental techniques and sensory awareness that Western science cannot fully explain or replicate. The astronomical knowledge required for precise celestial navigation involves understanding stellar positions and movements with mathematical accuracy that enables dead reckoning across vast distances. Traditional navigators memorized star maps of extraordinary complexity, tracking the movements of hundreds of celestial objects through seasonal cycles that repeated over periods of years or decades. This knowledge included not only the positions of individual stars, but understanding of how atmospheric conditions, seasonal changes, and geographical latitude affect stellar visibility and apparent motion. Recent research into traditional navigation techniques has revealed mathematical sophistication that rivals modern computational methods. Polynesian navigators developed mental algorithms for calculating position, direction, and distance that incorporate multiple variables, including time, weather patterns, ocean conditions, and celestial observations. These calculation methods enable real-time navigation decisions that maintain accuracy over voyages lasting weeks or months without sight of land. The cognitive capabilities required for such mental computation suggest either extraordinary human potential or access to technological aids that archaeology has not yet identified. The precision of ancient astronomical monuments demonstrates mathematical and engineering capabilities that could have supported advanced navigation technologies. Stonehenge achieves celestial alignments accurate to fractions of degrees, requiring computational abilities that enable precise prediction of astronomical events over periods of centuries. The Great Pyramid incorporates astronomical constants and Earth dimensions in its proportions with accuracy that was artificially achieved by European civilization until much later periods. Such monuments suggest technological capabilities that could have produced sophisticated navigation instruments, even if such devices have survived in archaeological record. Ancient texts occasionally describe navigation instruments and techniques that seem to exceed the technological capabilities conventionally attributed to their civilizations. Sanskrit texts describe navigation devices that sound remarkably similar to modern gyroscopic compasses, mechanical calculators for astronomical observation, and optical instruments for distance measurement. While conventional scholarship interprets these as mythological rather than technological descriptions, the mathematical precision they describe matches what would be required for accurate global navigation and mapping. The magnetic properties of certain ancient artifacts suggest possible technological applications that conventional archaeology has overlooked. Lodestones and magnetized metal objects found in ancient contexts sometimes show magnetic field orientations and strength distributions that seem too systematic to result from natural processes alone. Some researchers propose that ancient peoples developed magnetic navigation devices that utilized natural magnetic materials in sophisticated configurations that provided accurate directional orientation for oceanic navigation. Archaeological discoveries of ancient clockwork mechanisms, like the Antikythera device, demonstrate that classical civilizations possessed computational technologies of remarkable sophistication. The Antikythera mechanism performs astronomical calculations that enable prediction of planetary positions, eclipse cycles, and calendar correlations with accuracy that rivals modern ephemeris calculations. Such devices could have supported navigation applications that enabled accurate positioning and course calculation for global exploration and mapping applications. The optical properties of certain ancient materials suggest possible applications in navigation and surveying technologies. Crystal formations that exhibit precise optical characteristics appear in archaeological contexts associated with astronomical observation and navigation. Some ancient cultures developed techniques for grinding and polishing crystal lenses that could have provided magnification and light-gathering capabilities useful for celestial observation. Such optical technologies could have enhanced the accuracy of astronomical navigation techniques. Evidence of advanced ancient metallurgy includes materials with properties that seem to exceed what conventional understanding of ancient technology would predict. Damascus steel, Greek fire formulations, and various metal alloys found in ancient contexts demonstrate chemical and metallurgical knowledge that could have supported sophisticated instrument making. The precision required for accurate navigation instruments demands metallurgical capabilities that could produce gears, springs, and measuring devices with tolerances that approach modern manufacturing standards. The preservation of complex astronomical knowledge in oral traditions demonstrates information storage and transmission capabilities that rival written records for accuracy and longevity. The Aboriginal Australian songlines preserve geographical and astronomical information, with accuracy maintained over thousands of years through purely oral transmission. Similar traditions in other cultures maintain mathematical and astronomical knowledge with precision that enables accurate navigation and calendar calculation. Such oral technologies could have preserved navigation knowledge and techniques across periods when material instruments were lost or destroyed. Traditional accounts of ancient navigation often describe techniques and instruments that do not correspond to any known technology, but which seem to provide capabilities that accurate global exploration would require. References to sunstones that enable navigation during cloudy conditions, water compasses that indicate direction through fluid dynamics, and star wheels that mechanically calculate celestial positions suggest navigation technologies that may have existed but haven't been preserved in forms that modern archaeology can identify and understand. The electromagnetic properties of certain geographical locations may have provided natural navigation aids that ancient peoples learned to utilize in systematic ways. Magnetic anomalies, gravitational variations, and atmospheric electrical phenomena create location-specific signatures that could serve as navigation landmarks for peoples who developed sensitivity to such effects. Traditional navigators report awareness of subtle environmental changes that indicate proximity to land or specific geographical features, suggesting sensory capabilities that utilize natural phenomena as navigation aids. The possibility that ancient navigation technologies incorporated principles that modern science hasn't yet discovered or fully understood gain support from ongoing research into consciousness-based information acquisition. Studies of remote viewing, psychic archaeology, and intuitive navigation suggest that human consciousness may be capable of accessing geographical and directional information through non-physical means. If such capabilities were more developed in ancient cultures, they could have provided navigation accuracy that didn't depend upon conventional instruments or techniques. Whether ancient peoples possessed sophisticated navigation instruments that have been lost to archaeological record, developed consciousness-based techniques that enabled accurate global exploration, or had access to technological knowledge provided by more advanced civilizations, the evidence for precise ancient navigation and mapping capabilities continues to challenge conventional understanding of human technological development. The accuracy of ancient geographical knowledge, preserved in impossible maps, suggests navigation and surveying technologies that enabled systematic global exploration far earlier than conventional history acknowledges. In their precision and scope, these navigational achievements hint at technological capabilities that extended far beyond the simple techniques that conventional archaeology attributes to ancient civilizations. In the vast expanse of the Indian Ocean, where modern bathymetric surveys reveal underwater mountain ranges and submerged plateaus stretching between Madagascar and India, lies geological evidence of what may once have been one of Earth's most significant landmasses. The Kerguelen Plateau, the Mascarene Plateau, and other underwater formations create a chain of submerged territories that, if elevated above sea level, would form a continent rivaling Australia in size and complexity. This sunken realm, which 19th century biologists named Lemuria to explain the distribution of lemur fossils across widely separated Indian Ocean islands represents one of geology's most intriguing puzzles and one of lost continent theory as most scientifically plausible possibilities. The biological evidence that originally inspired the Lemuria hypothesis remains compelling even as geological understanding has evolved. Lemur fossils appear on Madagascar, India, and various Indian Ocean islands, but not in Africa or other regions that lemurs would have had to cross to reach their current island habitats. The distribution suggests that these primates once lived on continuous landmasses that connected the current islands, landmasses that have since been submerged beneath the Indian Ocean. Similar biogeographical patterns appear with other species groups, creating distribution puzzles that continental drift theory only partially explains. Modern geological surveys of the Indian Ocean floor have revealed topographical features that support the possibility of recent large-scale landmasses in the region. The Kerguelen Plateau, located in the southern Indian Ocean, covers an area of approximately 1.2 million square kilometers, roughly equivalent to the size of Alaska. Geological analysis indicates that much of this plateau was above sea level during recent geological periods, possibly as recently as 20 million years ago. While this time frame predates human civilization by millions of years, according to conventional chronology, it demonstrates that substantial continental landmasses have existed in the Indian Ocean within relatively recent geological time. The Mascarene Plateau, which underlies the current islands of Mauritius, Reunion, and the Seychelles, shows even more recent evidence of subaerial exposure. Geological samples from this plateau include continental-type rocks that formed under subaerial conditions, indicating that substantial portions were above sea level much more recently than the Kerguelen Plateau. Some geological evidence suggests that parts of the Mascarene Plateau may have been exposed as recently as 65 million years ago, when the mass extinction event that ended the dinosaur era was occurring. Recent discoveries have pushed the timeline of possible Indian Ocean landmasses much closer to the period of human civilization. In 2013, researchers analyzing sand grains from Mauritius beaches discovered zircon crystals that dated to 1.97 billion years old, far older than the volcanic island of Mauritius itself, which is only about 8 million years old. These ancient crystals must have originated from continental crust that existed beneath the current island, suggesting that fragments of ancient continental landmasses persist under what are now small volcanic islands. The implications become more intriguing when considered alongside evidence for rapid sea level changes during recent geological periods. During ice ages, global sea levels dropped by over 120 meters, exposing vast areas of continental shelf that are now submerged. In the Indian Ocean, such sea level changes would have dramatically altered the geography, potentially exposing large portions of underwater plateaus and creating extensive landmasses where only scattered islands exist today. Some researchers propose that portions of the Indian Ocean continental fragments remained above sea level much more recently than conventional geology acknowledges. The complex tectonic history of the Indian Ocean, involving multiple episodes of continental breakup, volcanic activity, and sea level fluctuation, could have created scenarios where substantial landmasses persisted into relatively recent times, before being submerged by geological processes that operated much more rapidly than gradual continental drift. The possibility of recent Indian Ocean continents gains additional support from ancient cartographic sources that show landmasses in the region where only ocean exists today. Medieval Arabic maps occasionally depict substantial islands or continental territories in the southern Indian Ocean, positioned approximately where geological surveys have identified major underwater plateaus. While these cartographic sources are often dismissed as speculative geography, their positioning corresponds remarkably well with actual submerged topographical features. Ancient Sanskrit texts contain references to lands and peoples in the Southern Ocean that could represent preserved memories of Indian Ocean continental territories. The Ramayana and other epic texts describe voyages to southern lands that possessed characteristics matching what large Indian Ocean landmasses would have provided extensive territories, diverse populations, and geographical features that seem too specific for purely mythological invention. While conventional scholarship interprets these as literary rather than historical accounts, they might preserve cultural memories of actual geographical conditions that existed when Indian Ocean landmasses were accessible. The Tamil literary tradition of South India contains particularly detailed accounts of Kumari Kandam, a vast southern continent that supposedly connected India with other lands across the Indian Ocean. These accounts describe not only the continent's general geography, but specific cultural, technological, and historical details that suggest preservation of actual historical memories rather than pure mythological invention. The Tamil accounts place the submergence of Kumari Kandam within the time frame of recorded human civilization, making them potentially relevant to understanding recent geological changes in the Indian Ocean. Genetic studies of Indian Ocean island populations have revealed patterns that support the possibility of recent large-scale landmasses in the region. The genetic diversity and distribution patterns of various species, including both animals and plants, suggest population histories that are difficult to explain through the current island geography alone. Some genetic evidence points to recent population bottlenecks and expansions that would be consistent with populations surviving on large land masses that were subsequently fragmented through submergence. Archaeological discoveries on current Indian Ocean islands occasionally yield artifacts and structures that seem to require larger populations and more extensive territories than the present island geography could support. Madagascar, in particular, contains archaeological evidence of sophisticated ancient civilizations that seem to exceed what the island as limited resources and isolated position would naturally generate. Such evidence could be explained if Madagascar was once part of a larger continental system that provided additional resources and population centers. Underwater archaeological investigations in the Indian Ocean region have begun to reveal structures and formations that may represent human-made features from periods when sea levels were lower. Sonar surveys have identified what appear to be constructed stone formations, arranged in patterns suggesting deliberate design rather than natural geological processes. While most of these discoveries remain controversial and subject to alternative geological explanations, they suggest the possibility that human civilizations existed on Indian Ocean landmasses that are now submerged. The climate implications of large Indian Ocean landmasses would have created conditions dramatically different from current geographical patterns. Substantial continental territories in the Indian Ocean would have altered weather patterns, ocean currents, and seasonal monsoons in ways that could have supported much more extensive and diverse ecosystems than the current scattered island geography provides. Such altered climate conditions could have supported advanced civilizations that had access to continental-scale resources and transportation networks. Recent advances in underwater survey technology continue to reveal new details about Indian Ocean bathymetry that support the possibility of recent large-scale landmasses. High-resolution sonar mapping has identified extensive flat-topped underwater mountains, plateau systems, and what appear to be drowned river valleys that suggest subaerial landscapes much more complex and extensive than simple volcanic island formation would create. These topographical features are consistent with continental landmasses that were submerged through relatively rapid geological processes. Whether the Indian Ocean once contained continental landmasses that persisted into the period of human civilization, supported advanced cultures that left only fragmentary traces in legend and underwater archaeology, or provided geographical conditions that conventional understanding of the region's history has overlooked. The accumulating evidence suggests that the Indian Ocean as geography has been far more dynamic and complex than simple models of stable island distributions would indicate. The possibility of another continent now largely submerged, but once accessible to human exploration. And habitation continues to challenge assumptions about the stability of geographical conditions and the completeness of our understanding of recent Earth history. In the quiet halls of the world's greatest libraries, ancient maps speak in languages that transcend the written word. They communicate through precise coastlines that shouldn't exist, accurate measurements that predate the instruments necessary to achieve them, and geographical knowledge that challenges every assumption about the capabilities and reach of past civilizations. These cartographic documents, scattered across cultures and centuries, may represent something far more profound than attempts to record contemporary geographical knowledge. They may constitute deliberate time capsules, messages encoded in mathematical precision and geographical accuracy, preserved across millennia to communicate truths about human history and planetary geography that oral tradition and written records could never maintain with such fidelity. The intentionality behind preserving geographical knowledge becomes apparent when we examine the extraordinary efforts ancient civilizations invested in creating and maintaining accurate maps. The mathematical sophistication required for global cartography exceeds what most ancient cultures needed for practical navigation or territorial administration. The resources necessary to conduct systematic global surveys would have represented enormous investments of time, personnel, and technological capability. Yet evidence suggests that multiple ancient civilizations possessed geographical knowledge of scope and accuracy that such comprehensive surveying efforts would produce. The encoding of astronomical constants in ancient architectural monuments demonstrates that past civilizations deliberately preserved mathematical and scientific knowledge in forms designed to survive civilizational collapse. The Great Pyramid incorporates the Earth's circumference, a mathematical constant pi, and various astronomical cycles in its dimensional relationships. Stonehenge encodes complex astronomical calculations in its stone arrangements. Similar monuments worldwide preserve mathematical and astronomical knowledge with accuracy that enables modern researchers to reconstruct ancient scientific capabilities. The same preservation instinct that created these architectural records could have motivated the creation of cartographic time capsules. The consistency of impossible geographical knowledge across multiple ancient sources suggests coordinated efforts to preserve specific information rather than accidental accumulation of accurate speculation. Maps showing Antarctica without ice appear across different cultures and time periods, with remarkable consistency in their depictions of coastlines and geographical features. The accuracy of these depictions exceeds what independent speculation by different civilizations could plausibly achieve, suggesting that mapmakers were working from common source materials or coordinated preservation efforts. Ancient texts occasionally describe the deliberate preservation of geographical and scientific knowledge for future generations. Egyptian papyri contain references to books of coming forth by day that preserve knowledge for use by future civilizations. Mesopotamian cuneiform tablets describe libraries created to maintain learning through periods of upheaval and decline. Similar preservation projects appear in various ancient cultures, demonstrating awareness that knowledge could be lost through civilizational collapse and conscious efforts to prevent such loss through systematic documentation and preservation. The mathematical encoding used in ancient maps suggests sophisticated understanding of how to preserve information in forms that would remain meaningful across vast time periods. Geographical accuracy provides a universal language that doesn't depend upon specific cultural or linguistic contexts for interpretation. Mathematical relationships embedded in map projections and coordinate systems create information storage methods that remain meaningful regardless of changes in measurement systems, languages, or cultural frameworks. Such encoding techniques demonstrate remarkable foresight about the requirements for long-term information preservation. The preservation of geographical knowledge through oral tradition in various cultures demonstrates alternative methods of maintaining accurate information across enormous time periods without dependence upon written records or physical artifacts. Aboriginal Australian songlines maintain geographical and astronomical knowledge with accuracy sustained over tens of thousands of years. Similar oral preservation systems in other cultures maintain mathematical, astronomical, and geographical information with precision that enables practical navigation and calendar calculation. Such oral technologies could have preserved the source material that ancient mapmakers incorporated into their cartographic time capsules. The mystery of source materials for impossible ancient maps suggests that cartographers had access to geographical knowledge that has since been lost to conventional historical record. The accuracy of Antarctic depictions requires either direct observation during ice-free periods or alternative methods of geographical information acquisition that conventional science doesn't acknowledge. If ancient civilizations possessed technological capabilities for global surveying that exceeded what archaeology attributes to them, the resulting geographical knowledge would represent an invaluable legacy worth preserving through extraordinary efforts. The timing of various impossible maps corresponds to periods of civilizational transition and upheaval that would have motivated knowledge preservation efforts. The Piri Reis map appeared during the Ottoman expansion period, when Islamic civilization was encountering European exploration efforts. Medieval European maps showing impossible geographical accuracy appeared during periods of social and religious transformation when classical knowledge was being recovered and preserved. The timing suggests that cartographic preservation projects may have been responses to threats of knowledge loss during periods of cultural change. The integration of geographical accuracy with religious and mythological symbolism in ancient maps suggests that cartographers deliberately embedded practical information within frameworks that would ensure preservation through cultural transmission. Maps that combined accurate geographical knowledge with religious significance would be more likely to receive careful preservation through periods when purely secular geographical documents might be lost or destroyed. The embedding of scientific accuracy within mythological frameworks represents a sophisticated strategy for long-term knowledge preservation. Modern discoveries of ancient technological artifacts suggest that past civilizations possessed capabilities that would have enabled global geographical surveying and systematic knowledge preservation efforts. The Antikythera mechanism demonstrates computational sophistication that could have supported astronomical navigation and geographical calculation. Similar devices may have existed, but haven't survived in archaeological record, representing technologies that enabled the comprehensive geographical knowledge preserved in ancient maps. The possibility that ancient maps preserve knowledge from civilizations that achieved global technological capabilities before recorded history challenges fundamental assumptions about human developmental timelines. If advanced human civilizations existed during earlier periods, when geographical conditions differed from current patterns, when sea levels were lower, Antarctica was ice-free, or continental configurations provided different possibilities for global exploration, their geographical knowledge would represent irreplaceable information about planetary conditions that no longer exist. The mathematical precision preserved in ancient cartographic sources suggests access to geodetic knowledge that approaches or exceeds modern surveying accuracy. The coordinate systems, distance calculations, and proportional relationships displayed in various ancient maps demonstrate understanding of the Earth's dimensions and geographical relationships with precision that systematic global surveying would be required to achieve. Such knowledge represents technological accomplishment that conventional archaeology attributes to much later historical periods. The preservation of geographical knowledge through periods of civilizational decline and recovery suggests conscious efforts to maintain scientific information across dark ages and cultural transitions. The accuracy of geographical knowledge preserved in medieval maps often exceeds what contemporary European civilization could have achieved through its own technological capabilities, suggesting inheritance of geographical information from earlier, more capable civilizations. This preservation pattern suggests that ancient maps may indeed represent time capsules carrying geographical knowledge across vast periods of human history. Whether ancient maps represent deliberate preservation of advanced geographical knowledge, encode information about planetary conditions that no longer exist, or communicate truths about human technological capabilities that conventional history has overlooked, they continue to function as messages from the past that challenge modern assumptions about the scope and continuity of human knowledge. In their mathematical precision and geographical impossibility, they suggest that the relationship between past and present human capability may be far more complex than linear models of technological progress would indicate. Preserving voices from earlier ages that possessed knowledge our current civilization is only beginning to rediscover and understand. The map unrolls in silence. Lines drawn centuries ago stretch across the parchment like veins of memory. The ink has faded, the paper has yellowed, yet the idea remains alive, an idea that refuses to vanish. It whispers of coasts unseen, of islands swallowed by time, of a continent that may still wait, somewhere beyond the horizon. Maps are more than tools. They are mirrors of imagination. Every curve, every shaded sea, every uncertain outline is not only geography, it is a reflection of how human beings once dreamed the world. And dreams, unlike coastlines, cannot be erased by tides. Centuries earlier, explorers set sail into waters marked only with dragons and warnings of the unknown. Their maps did not only chart seas, they charted fears, hopes, and possibilities. A blank space was never truly empty. It was a canvas for wonder. Those blank spaces called to us. They said, "Something is here." Even when nothing was certain, the possibility itself was enough to change the course of history. Consider the lost lands of Atlantis, Lemuria, Mu, each a name written into the imagination of different cultures, none proven, none forgotten. Like constellations in the night sky, they gave orientation, not through fact, but through story. And isn't that what maps are? Stories told in ink about what might lie beyond the known. Stories we continue to chase, even now, in an age where satellites trace every ridge of the earth. But even in this age of precision, mysteries remain. There are still trenches never touched by light, caves sealed for millions of years, ridges buried under polar ice, hidden like pages glued shut in the book of the world. We live with the illusion that the map is complete, that every secret has been uncovered. Yet history reminds us, whenever humanity has thought the world was fully known, the unknown has risen again, demanding to be seen. The idea of another continent stirs something deeper than geography. It stirs longing, a hunger not for land, but for discovery, because a map that is fully filled leaves no room for dreams. Perhaps this is why we invent legends of hidden continents. Perhaps we need the unknown as much as the known, to believe there is always more something, just beyond reach, something worth searching for. Meanwhile, the very earth moves beneath us. Continents drift, mountains rise, oceans swallow valleys whole. In the silence of geologic time, continents have appeared and disappeared before. There is nothing permanent in stone or sea. If it happened once, could it not happen again? Perhaps the ancient maps do not imagine too much. Perhaps they remember too well. Perhaps they echo lands that truly were, before the earth's restless shifting buried them from sight. And what of the stars? Civilizations long gone once aligned their monuments with constellations. They drew patterns between heavens and earth, between sky maps and sea maps. Perhaps they believed the two were mirrors, that to lose a continent below was to see its reflection above. Maps, then, are not just guides through space. They are guides through time. They carry memory forward, even when civilizations collapse, even when names are forgotten. A coastline marked on parchment may outlive the people who walked it. It may even outlive the land itself. Odd facts remind us how fragile certainty can be. Once, sailors believed California was an island. Once, phantom islands dotted the Atlantic, charted and erased, rediscovered and forgotten again. Even in the age of science, errors and mysteries persist. So why should the thought of a hidden continent be dismissed entirely? What if some of those errors were truths we no longer recognize? Consider the silence of the polar regions. Antarctica remains locked in its fortress of ice, revealing only fragments of what lies beneath. Beneath miles of frozen weight, mountains higher than the Alps are hidden. Lakes of liquid water remain sealed in eternal darkness. If such secrets exist beneath the South Pole, how much more could remain undiscovered across the planet? The horizon, it seems, is not only physical. It is also a horizon of knowledge, a limit we have not yet crossed. And so the maps endure, not because they are flawless, but because they remind us that the story of Earth is incomplete. Every misplaced coastline, every forgotten island, every suspiciously accurate detail in a world that should not have known, these are not only curiosities, they are invitations. Invitations to look again, to question again, to wonder again. Perhaps the real hidden continent is not land at all. Perhaps it is the vast expanse of the unknown itself, the ocean of questions that lies beyond every answer we think we hold. And in that sense, the secret maps reveal something far greater than geography. They reveal the truth of human curiosity, that we are not satisfied with what is, that we will always search for what could be. Picture the horizon at sea. The line where sky meets water is never truly reached. No matter how far the ship sails, the horizon stays ahead. It moves with us. It eludes us. It teaches us that some mysteries are meant not to be solved, but to be pursued. Maps may try to pin the horizon down, but the horizon itself is endless. And so the final question lingers. If there is another continent hidden, forgotten, or beyond reach, perhaps the greater discovery is not the land itself. Perhaps the greater discovery is this unyielding hunger to seek, to chase shadows across parchment, to listen to whispers in old ink, to look at a horizon and believe something waits beyond it. This is what makes us human, not the maps we finish, but the maps we continue to draw. The camera lingers on the rolled parchment, lit by the soft glow of a candle. The lines fade into darkness. The horizon stretches open. The story does not end. It simply points onward. If you enjoyed this journey into mystery, into memory, into the endless horizon, consider joining us again. For as long as maps remain unfinished, the search will always continue.